So what is object-oriented programming? Object-oriented programming is a programming paradigm or a style of programming that is centered around objects rather than functions. It's nothing new, it's been around since the 70s, but unlike tools and frameworks that come and go, object-oriented programming is still very relevant today. That's because it's not a programming language or a tool. It's a style of programming or a programming paradigm. There are several programming languages out there that support object-oriented programming, such as C#, Java, Ruby, Python, JavaScript, and more. Now, JavaScript is a little bit controversial, but I'll get to that later. It may interest you to know that many of the popular frameworks out there that you might be using are actually designed with object-oriented programming concepts in mind. Angular is an example of these frameworks. So object-oriented programming is a very popular style of programming, and it comes up in many technical interviews. So if you really want to be a serious developer, you need to understand object-oriented programming. As a technical interviewer myself, if I see a candidate with object-oriented programming on their resume, that candidate stands out to me. And that's where this crash course comes in. In this course, you're going to learn and understand object-oriented principles and how to implement them in JavaScript. My name is Mosh Hamedani, and I'm going to be your instructor in this course. If you enjoyed this video, please like and share it with others. And be sure to subscribe to my channel for new videos every week. You can also follow me on Twitter as Mosh Hamedani. So now, let's get started. A popular interview question concerns the 4 core concepts in object-oriented programming. These concepts are encapsulation, abstraction, inheritance, and polymorphism. Let's look at each of these concepts. Before object-oriented programming, we had procedural programming that divided a program into a set of functions. So we have data stored in a bunch of variables and functions that operate on the data. This style of programming is very simple and straightforward. Often it's what you will learn as part of your first programming subject at a university. But as your programs grow, you will end up with a bunch of functions that are all over the place. You might find yourself copying and pasting lines of code over and over. You make a change to one function and then several other functions break. That's what we call spaghetti code. There is so much interdependency between all these functions, it becomes problematic. Object-oriented programming came to solve this problem. In object-oriented programming, we combine a group of related variables and functions into a unit. We call that unit an object. We refer to these variables as properties and the functions as methods. Here's an example. Think of a car. A car is an object with properties such as make, model, and color, and methods like start, stop, and move. Now you might say, but Mosh, we don't have cars in our programs. Give me a real programming example. Okay, think of the local storage object in your browsers. Every browser has a local storage object that allows you to store data locally. This local storage object has a property like length, which returns the number of objects in the storage, and methods like setItem and removeItem. So in object-oriented programming, we group related variables and functions that operate on them into objects. And this is what we call encapsulation. Let me show you an example of this in action. So here we have 3 variables: base salary, overtime, and rate. Below these, we have a function to calculate the wage for an employee. We refer to this kind of implementation as procedural. So we have variables on one side and functions on the other side. They are decoupled. Now let's take a look at the object-oriented way to solve this problem. We can have an employee object with 3 properties: base salary, overtime, and rate, and a method called getWage. Now why is this better? Well, first of all, look at the getWage function. This function has no parameters. In contrast, in a procedural example, our getWage function has 3 parameters. The reason in this implementation we don't have any parameters is because all these parameters are actually modeled as properties of this object. All these properties and the getWage function, they're highly related, so they're part of one unit. So one of the symptoms of procedural code is functions with so many parameters. When you write code in an object-oriented way, your functions end up having fewer and fewer parameters. As Uncle Bob says, the best functions are those with no parameters. The fewer the number of parameters, the easier it is to use and maintain that function. So that's encapsulation. Now let's look at abstraction. Think of a DVD player as an object. This DVD player has a complex logic board on the inside and a few buttons on the outside that you interact with. You simply press the play button and you don't care what happens on the inside. All that complexity is hidden from you. This is abstraction in practice. We can use the same technique in our objects. So we can hide some of the properties and methods from the outside, and this gives us a couple of benefits. First is that we'll make the interface of those objects simpler. Using and understanding an object with a few properties and methods is easier than an object with several properties and methods. The second benefit is that it helps us reduce the impact of change. Let's imagine that tomorrow we change these inner or private methods. None of these changes will leak to the outside because we don't have any code that touches these methods outside of their containing object. We may delete a method or change its parameters, but none of these changes will impact the rest of the application's code. So, with abstraction, we reduce the impact of change. Now, the third core concept in object-oriented programming: inheritance. Inheritance is a mechanism that allows you to eliminate redundant code. Here's an example. Think of HTML elements like text boxes, drop-down lists, checkboxes, and so on. All these elements have a few things in common. They should have properties like hidden and inner HTML and methods like click and focus. Instead of redefining all these properties and methods for every type of HTML element, we can define them once in a generic object, call it HTML element, and have other objects inherit these properties and methods. So inheritance helps us eliminate redundant code. And finally, polymorphism. Poly means many, morph means form. So polymorphism means many forms. In object-oriented programming, polymorphism is a technique that allows you to get rid of long if and else or switch and case statements. So back to our HTML elements example, all these objects should have the ability to be rendered on a page. But the way each element is rendered is different from the others. If we want to render multiple HTML elements in a procedural way, our code would probably look like this. But with object orientation, we can implement a render method in each of these objects, and the render method will behave differently depending on the type of the object we are referencing. So we can get rid of this nasty switch and case and use one line of code like this. You will see that later in the course. So here are the benefits of object-oriented programming. Using encapsulation, we group related variables and functions together, and this way we can reduce complexity. Now we can reuse these objects in different parts of a program or in different programs. With abstraction, we hide the details and the complexity and show only the essentials. This technique reduces complexity and also isolates the impact of changes in the code. With inheritance, we can eliminate redundant code, and with polymorphism, we can refactor ugly switch case statements. To go through this course, all you need is a code editor and a simple web server. The editor that I'm going to use here is Visual Studio Code or VS Code that you can download from code.visualstudio.com. But feel free to use any editors. Now, with VS Code, we have this extensions panel here. Search for Live Server. This is a very simple and lightweight server that we're going to use to serve our application. So install this, and then here in the Files panel, let's add a new file, index.html. Now, to generate some basic HTML template, we can simply type an exclamation mark and press Tab. So a very basic HTML template. Now let's add a script element. So script with source set to index.js. We're going to write all our JavaScript code inside of this file. So let's add a new file and save it as index.js. And finally, to make sure that we have set up everything properly, let's do a console.log of hello world. Now, when you install live server, you should get this menu here in the status bar. If you don't see that, you probably have to restart VS Code. And if you still don't see it, simply right-click on index.html and select Open with Live Server. So this will fire up Chrome, pointing to this address. Now, let's open up Chrome Developer Tools. Here in the console tab, we've got Hello World. So, before going any further, I want to emphasize that this course is not for beginners, it's for intermediate level developers. So you should have at least 3 months of experience programming in JavaScript. You should know the basics, you should know how to use Chrome Developer Tools. I'm not going to cover these in this course. Our focus is purely on object-oriented programming with JavaScript. Alright, before we start our journey, let me explain how I've structured this course so you get the most out of it. In the next section, we're going to look at objects in JavaScript. Now, chances are you're familiar with some of the concepts that I'm going to explain, but please be patient, make sure to watch every lecture, because we're going to get really deep to make sure you have an in-depth understanding of objects, because objects are the foundation of object-oriented programming. Over the next 2 sections, we'll look at prototypes and prototypical inheritance. These are some of the complex parts of JavaScript that a lot of developers find confusing. So over these 2 sections, I'm going to make it super simple for you. Next, we will look at classes in ES6, which stands for ECMAScript 6. Now, if you don't know what is ECMAScript, ECMAScript is a specification developed by ECMA, which is an organization that defines standards for technologies. So ECMA as an organization has developed ECMAScript, which is a specification. Now, JavaScript is a programming language that conforms to the ECMAScript specification. Now, starting from year 2015, ECMA started to enhance JavaScript. So the specification that came out in year 2015 is referred to as ECMAScript 2015 or ECMAScript version 6. Now, in this specification, we have some new features in JavaScript. One of them is classes. But classes that we have in JavaScript are not like classes we have in languages like C# or Java, because JavaScript is a dynamically typed language. So classes are essentially syntactic sugar over prototypes and prototypical inheritance. So that's why we have 2 sections on these topics in the course. Once you master these, then we'll look at ES6 classes in section 5. And finally, we will finish this course by looking at modules. So this is the outline. Now I want to clarify something here. In this course, unlike my other courses, we're not going to build a real application. Because building a real application requires me to talk about various topics, such as building the user interface or the client app, then building APIs, working with a database, deployment, and so on. All these are distraction from the core of this course, that is object-oriented programming. So I wanted to create a short and sweet course for you to teach you object-oriented programming in JavaScript. That's why we're not going to build a real application, but to help you master the concepts that you're going to learn, in each section, I have designed 1 or 2 exercises. So make sure to spend some time doing these exercises, and you can also see my solution. With all that, let's get started. JavaScript is all about objects. So in order to learn object-oriented programming, first you need to have a good understanding of objects. So in this section, I'm going to cover some fundamental concepts around objects, such as creating objects, factories and constructors, primitives and reference types, and how they behave differently, working with the properties of an object, such as adding, removing properties, as well as enumerating them. You're also going to learn how to define private properties, as well as getters and setters. If you know all these topics well, feel free to skip this section and move to the next section where I talk about prototypes. Otherwise, continue watching. So now, let's get started. JavaScript is all about objects. So in order to learn object-oriented programming, first you need to have a good understanding of objects. So in this section, I'm going to cover some fundamental concepts around objects, such as creating objects, factories and constructors, primitives and reference types, and how they behave differently, working with the properties of an object, such as adding, removing properties, as well as enumerating them. You're also going to learn how to define private properties, as well as getters and setters. If you know all these topics well, feel free to skip this section and move to the next section where I talk about prototypes. Otherwise, continue watching. So now, let's get started. Let's start this section by creating an object. So I'm going to use the let keyword in ES6, which is the replacement for var. So in ES5 and before, we had var for declaring variables, but var has a number of issues when it comes to scoping. That's beyond the scope of this course. I just want to let you know that as a best practice, stop using var. Use either let or const. With const, you're basically defining a constant, so you won't be able to reassign it. If you want to reassign a variable, use let. Now in this demo, I'm going to use const to define a constant. So let's call this circle and set it to an object. Here I'm using object literal syntax. So these curly braces, we refer to them as object literal syntax. An object in JavaScript is essentially a collection of key value pairs. So inside these curly braces, I'm going to add a few key value pairs. Let's add radius and set it to 1. Let's add another key like location. Now this time the value can be an object. So again, I'm using object literal syntax. In this object, we can have a couple key value pairs like x and y. Now let's add another key value pair. So the key is draw. The value is a function that is for drawing the circle. So for now, let's just do a simple console.log. Now I want to define a few terms here. This circle object has 3 members: radius, location, and draw. If a member is a function, we refer to that as a method. So here we say draw is a method. These other members are what we call properties. Now in some JavaScript tutorials, they refer to all these members as properties, whether they're functions or not. But technically in object-oriented programming, properties and methods are fundamentally different because a property is used to hold values. A function or a method is used to define some logic. So now that we have this circle object, we can access its members using the dot notation. So circle dot, look, here are the members. We can call the draw method. Now note here on the right side, I've got Chrome open. This is Chrome Developer Tools. As soon as I save my changes here, you will see that Chrome is going to refresh because here with live server, we have hot reloading. So save, and here's the result. So as soon as we change our code, the new code is loaded inside Chrome. So object literal is a simple way to define an object. But we can also define objects using factories and constructors, and that's the topic for the next lecture. All right, now let's imagine we want to create another circle. With the current implementation, we have to duplicate all this code like this. Now, this can be a problem if we have one or more methods in our object. In this case, we have this draw method here. And as you can see, we have duplicated that in 2 different places. So if there is a bug in this method, we have to come back and fix it in multiple places. Now, this is a very simple object. Imagine if the circle object had 10 methods. So object literal syntax is not a good way to create an object and duplicate it if this object has at least 1 method. If an object has 1 or more methods, we say that object has behavior, like a person that can do different things. So it has behavior. Now let's imagine here we didn't have this draw method. Duplicating this object wouldn't be a big deal. So basically we would end up with 2 objects, and then here we could use different values. So creating objects with the object literal syntax is an issue only if that object has behavior. So what's the solution? The solution is to use a factory or a constructor function. So let me show you how that works. I'm going to delete this second circle and define a function called createCircle. Now I'm going to move all this code inside this new function, like this. Now we don't need to declare a constant, we can simply return this object. Now this circle requires a radius, so instead of hard coding 1 here, I'm going to add a parameter here, radius, and then set that here. Now in ES6 we have this new feature, so if the key and the value are the same, we can remove the noise in the code by removing the value. So we can only add radius. Now to simplify the code, so you can focus on what I'm going to teach you, I'm going to drop this location property. We don't really need it. Instead, I'm going to add our draw method. So key, value, and let's do a simple console.log, draw. Okay? So this is what we call a factory function. Now, we can simply call this function to create a new circle. So constant circle, we call createCircle and pass 1 as the radius. Now there is another way to create an object using a constructor function. So let's delete circle.draw and define a constructor function. I want you to see them side by side. So once again, we define a function, but the naming convention we use for a constructor function is different. The first letter should be uppercase. So we call it circle with an uppercase C. To developers with background in languages like C# and Java, this kind of looks like a class. However, as you can see, we're defining a function. In JavaScript, we don't have the concept of classes. So our circle function is going to take a radius parameter, but in the body, instead of returning an object, we're going to use the this keyword to set the properties of this object. What is this? This is basically a reference to the object that is executing this piece of code. You're going to see that in a second. So imagine we have a new empty object in memory. Now we're going to use this to reference that object and then use dot notation to set various properties on that object. So we can set the radius property to this radius argument. Similarly, we can define another property, draw, but this is more accurately a method, so we set it to a function. And here we do a console.log of draw. Okay? Now we can create a new circle like this. We use the new operator to call the circle function and pass 1 as the argument. When we use the new operator, a few things happen under the hood. This new operator will create an empty object. So, like this, an empty object. Then it will set this to point to that object, because by default, this points to the global object. If you're running this code inside of a browser, the global object is the window object. If you're running it inside a node environment, the global object is global. Let me show you. So I'm going to do a console.log of this. Let's see what happens. So save the changes. Now look, this is this circle object here. And here we have two members, draw and radius. This is because we used the new operator here. If I remove that, let's see what happens. So save the changes. Now this references the window object. So this is the global object in a browser. We don't want to use this. We don't want to mess up with this. We don't want to define global variables because they're bad practice, because they're available everywhere in our application. So it is possible that one function or another will modify the value of these variables accidentally and create a bug in our application. So when we use the new operator to call a function, three things happen. First, this new operator will create an empty object. Then it will set this to point to that object. And finally, it will return that object from this function. So note that here, we don't have an explicit return statement. We are not returning this. This will happen automatically when we use the new operator. So let me delete this. Also, we don't need console.log here. So basically, we have two ways to create an object. We can use a factory function or a constructor. There is nothing special about these. They're both regular functions in JavaScript. If we return an object in this function, we refer to that function as a factory function. In contrast, if we use the this keyword along with the new operator, we refer to that function as a constructor function. Now you might ask, what is the difference between these two patterns for creating an object? Which approach should you use? Well, it really depends who you ask. Developers coming from languages like C# and Java prefer the constructor function syntax because this looks like creating an instance of a class. But once again, in JavaScript, we don't really have classes. Other developers don't like this approach. They prefer to use factory functions. And one of their arguments is, what if a developer forgets to use the new operator here? Then we're defining these property methods on the global object, which is in this case the window object. But this discussion, this argument is really outdated. With the modern JavaScript and the tools that are available to us, we get an error if we forget to use the new operator here. So my suggestion to you is not to get hung up on these religious arguments about factories versus constructors. As a developer, you should be familiar with both these patterns because as you work on different projects and different teams, you will see both of these patterns for creating an object. So you should understand how they work. Choose the pattern that you prefer. Every object in JavaScript has a property called constructor, and that references the function that was used to construct or create that object. So here we have two objects, circle and another. Let's look at the constructor property. So here on the console, another dot constructor. So as you see, this returns our circle function that we used to create this object. Now let's look at circle dot constructor. What is this? Well, you can tell that this is a function because here we have this blue F. And as you can see, the first letter of this function is uppercase. So this is a built-in constructor function in JavaScript. When we create an object using the object literal syntax, internally, the JavaScript engine uses this constructor function. Let me show you. So I'm going to temporarily delete all this code. Let's define an object like this. When we use this syntax, object literal, JavaScript engine will translate that to something like this. Let x equals new object. Okay, so this circle object, we created and returned it from our factory function. And because we use the object literal syntax, internally it was created using this object constructor function. In JavaScript, we have a few other built-in constructors. For example, we have string for creating strings, but quite often we use string literals. So single quote or double quote or backtick. Using these literals is cleaner and simpler than using the constructor. We also have Boolean, but again, we don't use this. We either use true or false. So we refer to these as Boolean literals. We also have number, but instead we use number literals like 1, 2, 3, whatever. So this is what I want you to take away. Every object has a constructor property, and that references the function that was used to create that object. One of the confusing concepts in JavaScript is that here functions are objects. So this circle function we have here is actually an object. Don't believe me? Let me show you. So circle dot look, these are all the members of this circle function or circle object. So the purple icons are methods like call, bind, and apply, and the blue icons are properties. So let's take a look at a few of these members in the console. Here in the console, circle dot name, that returns the name of this function. Circle dot length returns the number of arguments. Now earlier in the last lecture, I told you that every object in JavaScript has a constructor property, and that references the function that was used to create that object. Now here's the interesting part. Who do you think created this object? Let's have a look. So circle dot constructor. So here we have another built-in constructor called function. And when we declare a function using this syntax, internally, JavaScript engine will use this function constructor to create this object. Let me show you. So I'm going to define a constant called circle1 to separate from our circle. Set it to new function. Now here our function requires one parameter, radius. So we add that here as a string. Now as the second argument, I'm going to pass the code inside of this function. So to break it up into multiple lines, I'm going to use the backtick character and then simply copy all this code and put it here. So when we declare a function internally, it's represented like this. Now we can call this circle1 just like calling our circle function. So we can create a circle object by newing up circle1 and pass 1 as the radius. Save the changes. Now in the console, let's log circle. Look, it's a real circle object with these two members. Now let's take a look at a couple of methods that are available in our functions. So I'm going to delete all this code. Circle dot. Here we have this call method. And with this, we can call a function. Look at the arguments. The first argument is this argument. Here we need to pass an empty object, and this will reference this object that we pass here. Okay? Now after that, we add our arguments explicitly. So here we have one argument, we pass 1. If we had multiple arguments, we would pass them explicitly like this. Okay? So this expression is exactly like expression on line 11. When we use the new operator, this new operator will internally create an empty object and pass that as the first argument to the call method. And this object will determine the context for this. So this will reference this object. Earlier, I told you that if you don't use the new operator, this by default will point to the global object, which is window. So if I want to rewrite this expression in this way, instead of passing an empty object, I would pass window. Of course, we don't want to do this. I'm just explaining to you what happens under the hood. So let's revert this back. So the first argument here specifies the target of this. Okay. Now we have another method called apply. It's exactly like the call method. With this, we can call a function, but instead of passing all the arguments explicitly, we pass them in an array. So this is useful if you already have an array somewhere else in your application and you want to pass that array as the second argument to the apply method. So this is the takeaway. In JavaScript, functions are objects. In JavaScript, we have two categories of types. On one side, we have value types, also called primitives. On the other side, we have reference types. So in the value types category, we have number, string, boolean, symbol, which is new in ES6. We're going to look at that later in the course, as well as undefined and null. These are the primitive or value types. On the other side, we have objects, functions, and arrays. So in the last lecture, you learned that functions are also objects. The same is true about arrays. So in a nutshell, in JavaScript, we have primitives and objects. Now in this lecture, I'm going to show you how primitives and objects behave differently, because this is absolutely important for you to understand before we move on to the next section where I talk about prototypes. So on this empty canvas, I'm going to define two primitives, x and y. I'm going to set y to x. So here y is 10. Now I'm going to change the value of x to 20. What I want you to note here is that x and y are two independent variables. So let's save the changes, go back in the console. Let's log x is 20, and y is 10. They are independent. So when we work with primitives, this value that we have here is stored inside of this variable. When we copy that variable, that value that is stored in the variable is copied into this new variable. So they are completely independent of each other. Now let's see what happens if we use a reference type or an object here. So I'm going to change this to an object that has a property called value. And then instead of setting x to 20, I'm going to set x.value to 20. So save the changes. Back in the console, let's log x. So you can see value property is 20. Now let's log y. You can see the value property of y is also 20. So this is the takeaway. When we use an object, that object is not stored in this variable. That object is stored somewhere else in the memory, and the address of that memory location is stored inside that variable. So then when we copy x into y, it's the address or the reference that is copied. In other words, both x and y are pointing to the same object in memory. And when we modify that object using either x or y, the changes are immediately visible to the other variable. So here's the conclusion. Primitives are copied by value. Reference types or objects are copied by the reference. Let's take a look at another example. So I'm going to define a function called increase that takes a number, and here we simply increase this number by 1. Let's declare a number variable and set it to 10, and then call increase and pass this number. Now, if I log this number on the console, what do you think we're going to see? Let's have a look. So save the changes. We see 10. But didn't we increase the number? Well, when we call increase and pass this number variable, its value is copied into this parameter that is local in this function. So this number variable here is completely independent of this other number variable. Here in this function, we increment number by 1, so it will be 11. But after this function, this number is going to go out of the scope. So when we log this number on the console, we're essentially dealing with this first number. So I told you that primitives are copied by their value. So here we're dealing with two independent copies. That's why we see 10 on the console. Now let's change this to a reference type or an object. So I'm going to change 10 to an object that has a value property. Okay, let's rename this variable to object. And similarly, I'm going to rename this parameter in this function to object, and then increment object.value. Now, when we log this on the console, what do you think we're going to see? We're going to see 11. See? We got this object with value 11. The reason for this is because when we call increase and pass this object is passed by its reference. So this local parameter that we have here will point to the same object that we defined here. So in this case, we are not dealing with two independent copies. We have two variables that are pointing to the same object. So any changes we make to this object will be visible to the other variable. So remember this. In JavaScript, we have value types, also called primitives, as well as reference types, which are objects. Our primitives are number, string, boolean, symbol, undefined, and null. Primitives or value types are copied by their value. Reference types or objects are copied by their reference. All right, so here we have our circle constructor function, and using that, we create a circle object. Now, these objects in JavaScript are dynamic. That means after you create them, you can add extra properties in them or delete some properties. You may be wondering why this is useful in the real world. Imagine you're working with a user object. The client, that can be a web or a mobile application, is going to send a user object to the server. On the server, we get this user object, and then we add additional stuff to it. For example, we can add a token property that we generate on the fly on the server. So we can always add something extra to an existing object. Because we don't have classes, we don't need to define these properties ahead of time. We can add them whenever we need them. And this makes JavaScript extremely powerful and easy to work with. In languages like C# or Java, every time we want to implement scenarios like this, we have to go back and change our classes. So here, let me add a new property to our circle object. We can set the location here like this. Save the changes. Now here on the console, let's log circle. All right, you can see here we have two properties, location and radius. We also have another notation for accessing properties, that is bracket notation. So another way to rewrite this code is like this. We use brackets and use a string to reference a property. So location. It's exactly the same. As you can see, the dot notation is simpler and less verbose than bracket notation, but this notation is also useful in certain scenarios. For example, when you want to dynamically access a property name. For example, let's imagine we have this constant called property name set to location. We have that somewhere in our application. Now we want to access the location property of a circle. If we're dealing with this dynamically, at the time of writing the code, we don't know what is the name of that property. That is calculated at runtime. So we can type something like this, circle.location. But what we can do is use the bracket notation. So we use circle, brackets, property, name. Another use case for using the bracket notation is when you're using the property names that are not valid identifiers. For example, let's imagine the name of this property is center-location. We can access this property like this, circle.center-location. That doesn't work. So if you have special characters or a space, that's when you use the bracket notation, okay? Now we can also delete a property from an existing object. A real-world use case for this is when you get a user object from a database and you want to return it to the client. But maybe that user object has certain properties you don't want to send to the client. You don't want to send the password, you don't want to send the credit card info. In that case, you will dynamically delete one or more properties from an object. So we use the delete operator and then reference the property name. So circle.location. Again, here we can use the dot notation or brackets. And of course, here we need a string. Sometimes you need to iterate over or enumerate the properties in an object. We can do that using the for in loop. So for let key in circle. So in every iteration, key will hold the value of one key in this object. Let's log that on the console. Okay, so look, we have radius and draw. So it's returning both properties and methods. Now, if you want to get the value of these properties, you can use the bracket notation. So here in console.log, I'm going to log circle of key. You learned in the last lecture that we can use the bracket notation to access a member. Okay, so save. Now you can see radius is 10 and draw is a function. What if we want to get only the properties and not the methods? Well, we can use the type of operator to check the type of this value. So if type of circle of key is not equal to function, then we will display it on the console. Save the changes. Now we get only the radius. There is another approach to get all the keys in an object. So this object that we have has a method called keys. We can pass our circle object here, and this will return all the keys in the circle as an array. So let's store them here and log them on the console. So here we have an array with two members, radius and draw. With this approach, you cannot separate properties from methods. Now finally, sometimes you want to know if an object has a given property. For that, we use the in operator. So if, here we add the name of the property as a string, if radius is in circle, we do a console.log of circle has a radius. Okay, save the changes, and here's our message. So remember, to enumerate all the members in an object, you can use a for in loop. To get all the keys in an object, use object.keys. And to check for the existence of a property or a method in an object, use the in operator. Sometimes you need to iterate over or enumerate the properties in an object. We can do that using the for in loop. So for let key in circle. So in every iteration, key will hold the value of one key in this object. Let's log that on the console. Okay, so look, we have radius and draw. So it's returning both properties and methods. Now, if you want to get the value of these properties, you can use the bracket notation. So here in console.log, I'm going to log circle of key. You learned in the last lecture that we can use the bracket notation to access a member. Okay, so save. Now you can see radius is 10 and draw is a function. What if we want to get only the properties and not the methods? Well, we can use the type of operator to check the type of this value. So if type of circle of key is not equal to function, then we will display it on the console. Save the changes. Now we get only the radius. There is another approach to get all the keys in an object. So this object that we have has a method called keys. We can pass our circle object here, and this will return all the keys in the circle as an array. So let's store them here and log them on the console. So here we have an array with two members, radius and draw. With this approach, you cannot separate properties from methods. Now finally, sometimes you want to know if an object has a given property. For that, we use the in operator. So if, here we add the name of the property as a string, if radius is in circle, we do a console.log of circle has a radius. Okay, save the changes, and here's our message. So remember, to enumerate all the members in an object, you can use a for in loop. To get all the keys in an object, use object.keys. And to check for the existence of a property or a method in an object, use the in operator. All right, now let's introduce some complexity in this example. So I'm going to define another property called default location, set it to an object like this. Also, let's define another method, compute optimum location. We set this to a function. And here we're going to do some magic. It doesn't really matter. What matters is that we're going to call this method inside of the draw method. So we call this dot compute optimum location. Now there is a problem with this implementation. Let me show you. So here, when we create the circle object, circle dot, these are the members of our circle object. Not all these members should be accessible to me as the consumer or the client of this object. For example, what would happen if I set default location to false? That's going to completely mess up with this object. Or as another example, maybe this compute method should only be called inside of the draw method. So if I accidentally call it here circle.compute optimum location, maybe this will put this object in a bad state. And then if I call circle.draw, we're going to get a weird error at runtime. So in object-oriented programming, we have this core concept called abstraction. Abstraction means we should hide the details and complexity and show or expose only the essentials. In this particular example, we should hide this property, default location, as well as this method. These are implementation details. These are part of the complexity of this object. We want to hide these from the consumers of this object. Instead, we want to expose only the essentials. That is the radius and the draw method. Let me give you a metaphor. Think of a DVD player. A DVD player has a complex logic board on the inside, but only a few buttons on the outside that you interact with. So what we have on the inside is the implementation detail, and what we have on the outside is the public interface of a DVD player. We want our objects to look like this DVD player. We want to hide all the details, all the unnecessary complexity on the inside, and expose only a few members or a few buttons on the outside. A lot of developers who have not been able to apply object-oriented programming effectively have failed to comply with this principle. Everything in their objects is public and accessible from the outside. And this will bring a number of issues. One issue is that every time you change the implementation of that object, you have to go and modify many different places in your code. For example, let's imagine now this compute method requires an argument. Let's add a factor argument here. With the current implementation, because we can access this from the outside, everywhere we have used this method, we have to come back and pass an argument. So one simple change in the implementation of an object results in a number of changes in your source code. In contrast, imagine if this method was not accessible from the outside. Then we wouldn't have to modify this line. We would only modify line 12, where we have called this function, right? So remember the abstraction principle of object-oriented programming. Hide the details and expose only the essentials. In the next lecture, I'm going to show you how to implement this in JavaScript. So how do we implement abstraction here? You want to hide certain members from the outside. So earlier you learned that this references that new circle object. Now what happens if I declare a local variable in this function? Let's say color, we set that to red. Is this going to be part of that object? Of course not, because we have not set that as a property on that object. We didn't set this.color to color, okay? So this is only a local variable inside of this function. When we get out of this function, this variable goes out of scope and dies. Now with this technique, we can easily hide certain members from the outside. So default location is implementation detail. We don't want this to be accessible from the outside. Instead of setting it as a property on our new object, we define it as a local variable here, okay? Now we don't need this color anymore. By the same token, we can convert this method to a private method. So let compute be a function. Now, here in the draw method, we're calling compute optimum location. This function will no longer be a method on this new object, so we can access it using this. We have to access it directly here. This will work because in JavaScript, we have this concept of closure. If you don't know closure, let me simplify it for you. So here we have one function and another function inside of that function. In this function, we can declare certain variables like x and y. And these are local variables that are only available in this function. Their scope is limited to this function. So when we finish executing this function, x and y will go out of scope. In contrast to scope, we have closure. A closure determines what variables will be accessible to an inner function. So this function will be able to access all the local variables defined here, as well as the variables defined in its parent function. So here we declared two variables, compute optimum location, which is a function, as well as default location. These are the variables that are defined in this parent function. They are within the scope of this function, but within the closure of this inner function. Now, don't confuse closure with a scope, because the scope is temporary and it dies. So every time we call the draw method, these variables will be recreated and reinitialized. And then after this function, they will die. So scope is temporary, but closure stays there. So when we call the draw function, after we finish executing this function, these variables will continue to stay in memory. They will preserve their state because they're part of the closure of this draw function. Okay, so back here. So in this method, if you want to access those private members, you simply use them here. You can also use default location. But if you want to access members of this new circle object, you need to use this. So this.radius as an example. Okay, now with this simple change, we basically replace this with let. Let's see what happens. If we access the members of the circle object, we only see draw and radius. So the public interface of this object is simpler, is easier to work with, and this will also prevent issues later down the road. So in the last lecture, we converted these two members to private members. Now, more accurately, these are not private members of the circle object because technically they are not inside of a circle object. They are local variables that we have defined inside of this circle function. But from an object-oriented point of view, we can refer to them as private members of the circle object. Now, I want to simplify the code here so we can focus on a small issue. I'm going to delete this compute function, right? So we have this private property, default location. We cannot access this from the outside. But what if we want to display that default location somewhere in our application? So we don't want to modify it, we just want to be able to read it. So one solution is to define a method here, this.getDefaultLocation. We set it to a function. And in this function, we simply return default location. Once again, we're dealing with an inner function here. The closure of this function includes all the variables defined here, as well as all the variables defined in its parent functions. So here we have access to default location. And with this, we can call circle.getDefaultLocation. However, I don't like this syntax. I don't like the fact that we're calling this as a method. It would be nicer if we could access this property like this, default location. But we shouldn't be able to set this from the outside. We can only read it. So let me show you how to define a property like that. So this object that you have seen so far has a method called define property. we have another method called define properties if you want to define multiple properties in one go. Now, the first argument to this method is the object that we want to add a new property to. That object is the one that is referenced by this, the new circle object, right? So we pass that here. The second argument is the name of our property. We want to call that default location. And the third argument is an object. In this object, we add a key value pair. The key is get. This is a special keyword for JavaScript. And the value is a function. So when we access circle.defaultLocation, this function will be called. Okay? Now here we can simply return default location. Again, this variable is part of the closure of this inner function. So here we can access it, right? Now in VS Code, you don't see that in IntelliSense. So we don't have default location as a property. However, if we save the changes, oops, I made a mistake here. Actually, I should have used define property. So save the changes. All right. So now look at the circle object. Circle. So here's our new property, default location. You can see dot, dot, dot in front of it because this is a computed property. When we click this, that get function will be executed. And here's the result, our default location. Okay. Also, you can see that function is stored here as a getter. So a getter is a function that is used to read a property. So this property we have here, default location, we refer to this as a read-only property. Now, if you want to set the value of this property from the outside, we define a setter. So in this object, we add another key value pair. The key is set, which is a special keyword, and the value is a function. Now this function takes an argument called value. We can set this default location to this value. But what is interesting is that because we are using a function, in this function, we can perform some validation for this value before setting the default location. For example, we can write a simple logic like this. If value.x is falsy or value.y is falsy, we can throw a new error. Again, error as a built-in constructor that we use to create error objects. We pass a string invalid location. So this is the benefit of a setter. Now we can come here and set circle.default location. Let's see what happens if we set this to 1. Save the changes. And here's our error, invalid location. So to recap, use object.define property to define getters and or setters. All right, here is a great exercise for you. I want you to use what you have learned in this section and design a stopwatch object like this. So let me show you how this behaves. I'm going to define a constant called SW and set it to a new stopwatch. So that's our stopwatch object. Now, this object has a few members: duration, which is a property, as well as 3 methods: reset, start, and stop. And the other members you see here, they are inherited from the base object. Okay? Now, initially, duration is 0. We can start the stopwatch. Now, at this time, if we call start again, it's going to scream at us. Stopwatch has already started, so we cannot call start twice. Now we can call stop, and again, we cannot call stop twice in a row. It's going to complain because stopwatch is not started. Now we can access the duration property, so stopwatch, so stopwatch dot duration. So this stopwatch counted 19 seconds from the moment I called the start method until I called the stop method. Now we can repeat. So If we call start again, now it continues counting, and then we call stop, and then let's look at the duration again. Now it's a total of 20 seconds. We can also call reset, and this takes the stopwatch to its initial state. So we can call start, and then stop, and then look at the duration. Only 2 seconds, okay? So this is how the stopwatch works. Now I want you to go ahead and spend about 30 minutes on this exercise. Use what you have learned and do your best to implement an object that behaves like this. In the next lecture, I'm going to show you my solution. All right, here's my implementation of the stopwatch object. Now, don't worry if your implementation is different from mine. Chances are it's going to be different because there is no one solution to a given problem. As long as your stopwatch behaves like what I showed you in the last lecture, and it has a clean implementation, your solution is perfectly fine. So here we have a function called stopwatch. This is a constructor function. I have defined a few private variables here: start time, end time, running to see if the stopwatch is running or not, and duration, which I have initially set to 0. You can see we have 3 methods here: start, stop, and reset. And I've also defined a read-only property called duration. Look, here we have a getter, which simply returns this duration, which is a local variable in this function. Okay, now let's take a look at the implementation of each of these methods. So start. First, we have a validation check. If the stopwatch is running, we simply throw a new error with this message: stopwatch has already started. Otherwise, we set running to true and set start time to the current date time. Very simple implementation. The stop method is very similar. So first we have a validation check. If it's not running, obviously we cannot stop it. That's why we throw a new error. Otherwise, we set running to false. Next, we set end time to the current date time. And then we calculate the seconds between the end time and start time. So we call end time.getTime and subtract it from start time.getTime. This expression returns the milliseconds between these two date objects. So we divide it by 1,000 to get the seconds, and then add that to the duration variable which we defined earlier. And finally, let's take a look at the reset method. Here we simply set these variables to their initial value. So we set start time and end time to null, running to false, and duration to 0. So once again, if your implementation is different, don't worry. There is no one best solution to a given problem. If I come back and solve this problem in a month from now, chances are my implementation is going to be different from what you see right now. Inheritance is one of the core concepts of object-oriented programming that enables an object to take on the properties and methods of another object. And this makes it easy to reuse code in different parts of an application. Here's a real example. In the last section, we defined this circle object with this method, compute optimum location. Now for this discussion, let's imagine here we're working with a class. So let's imagine circle is a class and not an object. I want to explain inheritance in its classical terms. So we have the circle class with one method, compute optimum location. Let's imagine tomorrow we're going to add another class to our application called square. And square also needs this method, compute optimum location. For now, let's imagine the implementation of this method is exactly the same across these two different classes. We don't want to repeat this implementation because if there is a bug in this implementation, we have to fix it in multiple places. Or if we decide to change the implementation and make it better, again, we have to repeat this in different places. So that's when inheritance comes to rescue. We can define a new class called shape, put this method there, and have circle and square inherit this method from the shape class. Now in inheritance, we have a few terms that you should be familiar with because I'm going to use these terms throughout this course. In this diagram, we refer to the shape class as the base class or superclass or parent class. All these terms are exactly the same. Different tutorials and different books use different terms. In contrast, we refer to the circle as the derived class, or subclass, or child class. And finally, we refer to the inheritance relationship as is a relationship. So we say circle is a shape. Now this is the classical definition of inheritance. But as you know, in JavaScript, we don't have classes, we only have objects. So that's when prototypical inheritance comes into picture. So essentially we have two types of inheritance, classical and prototypical. And that's one of the topics for interview questions. So what is a prototypical inheritance? That's the topic for the next lecture. So in the last lecture, we talked about the circle and shape classes. But in JavaScript, we don't have classes, we only have objects. So how can we implement inheritance only using objects? Well, here we have a circle object. We can define another object, let's call it shape, and add all the common behavior or all the common methods in this object, like compute optimum location. And then somehow we can link the circle object to the shape object. Now we refer to the shape object as the prototype of the circle. So a prototype is essentially a parent of another object. A lot of courses and tutorials make prototypes sound so confusing and complicated. It's not. Whenever you hear the word prototype, just think parent. So every object in JavaScript, except only a single object that I'm going to show you in a second, has a prototype or parent, and it inherits all the members defined in its prototype. Let me show you this in action. So here in Chrome Developer Tools on the console, I'm going to define a new object, just an empty object. Now let's inspect this. So look, here we have a property called proto. Note that this property is faded because it's deprecated and you shouldn't directly access it. It's only available here to help you troubleshoot problems. So let's expand this. All right, look, this is the prototype or parent for this X object that we created here. We have these properties and methods like constructor. You saw that in the last section. So every object has a constructor property which references the function that was used to construct or create that object. We also have this method here, toString. So let's use that method. We can type x.toString. And this is the default implementation of toString method. So we have this X object in the memory, and X has a link to another object, which is its prototype. For our discussion, let's call this object object base. It's not an official term. You're not going to find it anywhere. It's just a name I'm going to give it for our discussion. So every object that we create in JavaScript directly or indirectly inherits from object base. Object base is the root of all objects in JavaScript, and it doesn't have a prototype or parent. Let me show you. So one more time, let's inspect X. Okay, here is its prototype, which is our object base. Look, this object doesn't have a proto property. So it doesn't have a prototype or a parent. Now we can create another object here. Let's call this Y. Again, another empty object. Let's inspect it. So Y also has a prototype property, which is the same object base that you saw a few seconds ago. So here's what we have in memory. We have X and Y, and both these objects reference object base. So we have a single instance of object base in memory. I can prove that to you. So back in the console, to get the prototype of an object, we call object.getPrototype of. And here we pass X. So this is our object base with these members. Okay, now we can write an expression like this. Object.getPrototype of X. We can check if it's equal to object.getPrototype of Y. Look, both X and Y have the exact same prototype. Now you might be wondering why I didn't write this expression like this. X._proto equals Y._proto. The The reason for this is because this property is deprecated, so you shouldn't use it in the code. But you can use it here on the console when debugging your applications. So now that you understand what a prototype is, let's define prototypical inheritance. So earlier, I accessed the toString method on the X object. We didn't define this method in our X object because X was an empty object, right? So how does this work? How can we access this method? Well, when we access a property or a method on an object, JavaScript engine first looks for that property or method on the object itself. If it can't find it, then it looks at the prototype for that object. Again, if it can find that member, it will look at the prototype of that object all the way up to the root object, which we called object base. So this is prototypical inheritance in action. When accessing a property or a method on an object, JavaScript engine walks up the prototype chain to find the target member. So once again, I want to emphasize that a prototype is just a regular object in memory. There is nothing special about it. Every object has a prototype or a parent except the root object. Let's take a look at another example. I'm going to define an empty array. Let's call this my array. Now let's inspect this. All right, so here we have a prototype property. Let's look at the prototype or the parent for this array. Okay, look, in this object we have these methods. Chances are you have used some of these methods before. For example, we can call index of to locate an object in an array. We can call push to add a new object to the array, and so on. So all these methods are defined in this object, which is the prototype or the parent for all arrays in JavaScript. So this is what we have in memory. We have my array, which derives from, let's call this object array base. Now let's inspect the prototype of the array base object. So back here, if you scroll down, look, here we have another proto property. Let's expand this. What do you see here? That looks familiar, right? This is our object base or the root object in JavaScript. So here's a visualization of what we have in memory. My array derives from array base, and array base derives from object base. This is what we call multi-level inheritance. What about the objects that we create using our custom constructors? So here we have this constructor circle, and we have created the circle object using this constructor. So let's inspect this on the console. So circle, here's our circle object. It has a prototype. Look, this prototype is the prototype for all circle objects that we create using our circle constructor. Let's call this circle base. So every time we call the circle constructor to create a new circle object, this constructor will create a new object and set its prototype property to circle base. In other words, objects created by a given constructor will have the same prototype. So all circle objects created by the circle constructor will have the same prototype. And similarly, all arrays created by the array constructor will have the same prototype. Now back here, so this is our circle base. Circle base also has a prototype. Let's see what we have here. What is this object? That's object base, right? The root object in JavaScript. So this is what we have in memory. We have the circle object that inherits from circle base, and circle base inherits from object base. All right, now let me show you something interesting. So I'm going to define a new object like person and set its name to Mosh. Let's log it on the console. Person. So here's our person object, and in its prototype, we have all these methods available. So we can type person.toString and it works. However, if we iterate over the members of this object, we're not going to see this method toString. So a for loop, let key in person. Let's just log the key on the console. Save. So the only key we have here is name. None of the properties and methods defined in object base are visible here. By the same token, if we call object.keys of person and then log it on the console, again, we only see the name property. So how come we can't iterate over all these properties and methods defined in object base? Well, the reason is because in JavaScript, our properties have attributes attached to them. Sometimes these attributes prevent a property from being enumerated. Let me show you what I mean. So first, let's get the prototype for person. We call object.getPrototype of person. So this is our object base, right? Now I want to show you the attributes attached to the toString property, or more accurately, toString method. So we call object.getOwnProperty descriptor. So as the first argument, we pass object base. As the second argument, we pass the name of the target property or method, that is toString. And this will return an object which we call a property descriptor. Let me show you. So let's store that in descriptor. So now let's log this descriptor on the console. Okay. So here's our descriptor object. Look at the properties. Configurable is true. That means we can delete this member if we want to. Enumerable is false. And that's why when we iterated over our person object, we couldn't see the toString method. We also have writable set to true, which means we can overwrite this method. We can change its implementation. We can set its value. And here's the value property, which is set to a method. And this is where we have the default implementation of the toString method. Now, when you create your own objects, you can set these attributes for your properties. Let me show you an example. So we're going to use our person object. We don't need these lines anymore. Earlier in the last section, you learned about object.defineProperty method. We use this to define a getter and a setter for a property. So as the first argument, we pass person. The second argument is the name of the target property, which is name. And the third argument is an object, which is our property descriptor object. This is where we add the attributes to this property. So in the last section, we used get and set to define a getter and a setter. Now we're going to use different set of properties. So I can set this to writable, false, and this will become read-only. So if I set person.name to, let's say, John, and then log it on the console, okay, look, the name is not changed. So that's the writable attribute. We have another attribute, enumerable. We can set this to false, and then this will not show up in object.keys. So if we log object.keys of person, look, now we get an empty array. In contrast, if it was true, it will show up here. So by default, all these attributes are true. All properties are writable, enumerable, and configurable. So let's see what happens if we set configurable to false. Now we cannot delete this property. So if I try to delete person.name, nothing will happen. So let's log the person on the console. Look, the name property is still there. So you have learned that every object in JavaScript, except the root object, has a prototype or a parent. Now the proper way to get the prototype of an object is using object.getPrototype of, and here we pass an object, right? And what we get here is exactly what we saw in Chrome console under myObject.__proto property. It's the same thing, right? So what we have here is the prototype or the parent of my object, right? Now, one thing you need to know, is that constructors also have a prototype property. So here we have the circle constructor function. And you know that in JavaScript, functions are objects. So they have properties and methods. So here we can type circle dot. Look, these are all the properties and methods that are available in every function. So here's the prototype property. What is this? This is the object that will be used as the parent for objects created by the circle constructor. So back here, if I want to put this together, assuming that we have this myObject, and this myObject is created by this constructor has a prototype property, and what we get here is exactly what we have here. So the object that will be used as the parent for objects created by this constructor. Let me show you this in action. So I'm going to define an object, an empty object. This object has a prototype property, which is its parent. And you know that this is what we call object base, right? So we have these members like constructor has own property and so on, right? Now, you know that this object is created using the object constructor function, right? So when we use the object literal syntax, under the hood, that's translated to a new object, right? So that's our constructor. Now this constructor has a prototype property, and this is the object that will be used as the prototype for all objects created by this constructor. So look, this is our object base, right? So what I'm telling you is that both these are equal. The parent for this object and the prototype for this constructor. Let's take a look at another example. So I'm going to define an array, empty array. This array has a prototype, proto, and this is the object that includes all the methods that can be called on arrays, right? So we call this array base. Now, when we use an array literal, under the hood, the array constructor will be called. Now this constructor has a prototype property which references array base, the same object, okay? Now finally, as one more example, here we have a circle object. Circle has a prototype. We call the circle base, which doesn't have anything specific here. It only has this constructor property. Now, we created the circle object using circle constructor. This constructor has a prototype property which returns circle base. So these two objects are exactly the same. Now we have this circle constructor with two members, the radius property and the draw method, just like before, and we have two circle objects. So let's log these objects on the console. C1, here's our object. We have this draw method. Let's log C2. And you can see we have this draw method here as well. So with the current implementation, if we have, let's say, 1,000 circle objects in the memory, we're going to have 1,000 copies of the draw method. Now, this is a very simplified example. In a real-world application, your objects might have several methods. So if you want to have a large number of these objects in the memory, you're going to waste a lot of memories by keeping copies of all these methods. So what's the solution? Well, you know how prototypical inheritance works. When we access a property or a method on an object, JavaScript engine first looks at the object itself. If it can't find that property or method, it will look at the prototype of that object. So now we can take this draw method out of the circle object and put it in its prototype. We're going to have a single instance of this prototype in the memory, which we call circle base. So we're going to have a single instance of the draw method. So how do we do that? Well, in the last lecture, you learned that every constructor has a prototype property. So circle.prototype. And this is exactly the same as the prototype of our circle objects. So for C1, let's say if we access the proto property, which we shouldn't because it's deprecated, But essentially, these two properties are referencing the same object in memory. That's the circle base. So using circle.prototype, we can quickly and safely access this object. So you know that JavaScript objects are dynamic, so we can always add something to them later. So we can add the draw method here and simply move the implementation right here. And with that, we no longer need the draw method on the object instance itself. Save. So now let's log our circles one more time. C1. This object only has a radius property. The draw method is on the prototype, the circle base object, right? And the same is true for C2. Again, we don't have the draw method, it's on the prototype. Now, because of the prototypical inheritance, we can still access it. So we can call c1.draw and everything works. So essentially we have two kinds of properties and methods in JavaScript. We have instance properties and methods. Let's call them instance members and prototype members. Now let's take this to the next level. So you know that every object has this toString method. So c1.toString, by default, it returns this string here. We can overwrite the implementation of this method in the prototype of our circle objects. So here I'm gonna add circle.prototype.toString, set it to a new function. And here we're gonna return circle with radius. Now we need to access the radius property. So we can use this dot radius. Save the changes. Now c1.toString. And this is the new implementation. So back to our prototypical inheritance, when we call this method, JavaScript engine looks at our circle object. Obviously, we don't have this method there. Then it looks at its prototype. So circle.prototype. We have implemented this method here, so this implementation will be used. So here's the interesting part. Even though we have another implementation of the toString method on object base, but this implementation will be used because this is more accessible. So this is all about instance versus prototype members. And by the way, remember that in both these kind of members, you can reference other members. For example, in the draw method, which is a prototype method, I can easily call an instance method on the circle class. So let's add a method here, call it this.move. We set it to a function, console.log of move. Now we can reference this function or this method more accurately in our prototype method. So this.move and then console.log of draw. So let's test this. c1.draw. And here are our two messages, move and draw. By the same token, in an instance method, we can reference a prototype member. So let's reverse this. Here, before moving the circle, we want to draw it. So we call this.draw. Now, essentially what is happening here, we're calling the draw method. Obviously, it's not an instance method. So the JavaScript engine will find this method on the prototype. So everything will continue to work. To demonstrate this, let's go back to the draw method. We shouldn't call move because otherwise we'll have a circular dependency. So delete this, save the changes. Now c1.move. So we have draw and move. So I've simplified the example from the last lecture. We have the circle object with two instance members, radius and move, and one prototype member, which is called draw. Now, one thing I want to emphasize here is that it doesn't matter when you change the prototype. So in this case, we're modifying the prototype before creating an object. We could create an object first and then modify the prototype. The draw method will still be available on this circle object, because here we're dealing with object references. So we have a single object in memory. As soon as we modify that, all the changes are immediately visible. So save the changes. Look, we've got the draw message here. Now in this lecture, I'm going to show you how to iterate over instance versus prototype properties. So earlier you learned about object.keys method. I'm going to pass this C1 here. Let's see what we get on the console. Save. So object.keys only returns instance members, radius and move. Draw is not there because draw is a prototype member. So that's something I want you to remember. So object.keys only returns instance members. Okay. What about the for in loop? Let me show you. So for let key in C1, let's just do a console.log of the key. All right, look, here we have all the instance and prototype members. So we get the draw method as well. So remember, the for in loop returns all members, instance and prototype. Now in JavaScript language, we often use the word own instead of instance. So in some documents, in some tutorials, you may hear own property versus prototype property. Let me show you a useful method. So here, let's call C1 that has own property. We pass the name of the property. Let's say radius. This is an instance or own property, so we get true. But if we call has own property and pass draw, we should get false because this is a prototype member or a prototype property. So you have learned how easy it is to modify the prototype of an object. So you might be tempted to do something like this. So array.prototype.shuffle, we're going to add a new method to our arrays for shuffling an array. Now let's not worry about the algorithm for shuffling an array. Now, with this, we can define an array like this, and we'll be able to call the shuffle method. Now, while this is very easy to accomplish in JavaScript, that's something you should avoid. You should not modify the built-in objects in JavaScript, because it is possible that tomorrow you're going to use a library, and in that library, someone has also extended the array prototype and added a shuffle method, but with a different implementation. Then you will end up spending the whole day debugging the problem. Also, nothing stops the developers of JavaScript from adding this method to arrays in the future versions of JavaScript. So here's the lesson. Don't modify objects you don't own. Yes, JavaScript is a dynamic language. It makes it really easy to add properties and methods to an existing object, but that doesn't mean that you should modify the built-in objects. So don't override methods, don't add new methods or properties, and don't remove existing properties and methods, because somewhere else in a library you might be using, there might be code that is dependent on those methods in the built-in objects. So if you modify the built-in objects, you will create all sorts of issues. Now it's time for an exercise. So here's the stopwatch object that we created in the last section. Now, in this exercise, I want you to move the methods we have here, like start, stop, and reset, to the prototype of the stopwatch. Now, before we get started, I want to clarify something. You should put methods on the prototype as an optimization technique. So if you're working with a large number of objects of the same type, you don't want to have multiple copies of these methods in memory. In case of a stopwatch, we don't really have that requirement. If we're going to use stopwatch in a program, we need only one instance. So in this case, we don't really need to put these methods on the prototype. And as you will see, putting these methods on the prototype will lead to another issue. And that's part of the exercise you're going to work on. So go ahead, put these methods on the prototype, and then notice that you will not be able to access these variables like running and start time, because these variables are defined in this function. They are within the scope of this function. When you put the start method on the prototype, you can only access the public members of the stopwatch. So in order to access running, you need to define this as a public read-only property on the stopwatch and then access it using this. So that was a quick hint for you. Go ahead, do this exercise, and you will see my solution next. All right, so here's my solution. I'm going to select these three methods: start, stop, and reset, and move them outside of this function. Now, I'm going to replace this dot with stopwatch dot prototype dot. And by the way, I used multi-cursor editing here if you didn't notice. So you can see here we have multiple cursors. That's a quick way to edit multiple items at the same time. The way you do this is you select something and then press Command and D on Mac or Control D on Windows. Actually, I'm not quite sure about the shortcut on Windows because I don't use Windows. But if you look at the top menu, under the selection menu, look, this is the shortcut I'm referring to, add next occurrence. So you select something. Here I have selected stopwatch.prototype. Now we press Command and D. And here we have another selection, one more time. And this is the third selection. Now we can replace all of this together or revert it back. Okay, so these methods are now on the prototype for the stopwatch. As you can see, running is not defined anywhere in this function. It's defined here, and we don't have access to that. That's why we need to define this as a read-only property, just like how we have exposed the duration variable as a read-only property here. We need to expose these other variables as read-only properties. Now, the problem with this is that it's going to pollute the interface of the stopwatch. In our previous implementation, our stopwatch had only 4 public members, 3 methods, start, stop, and reset, and 1 public property, that's the duration. Now we're going to add 3 extra properties, and this is going to pollute the interface of stopwatch. And this is against the idea of abstraction in object-oriented programming. Because as we explained earlier, we want to keep the interface of our objects clean and simple, just like a DVD player. We don't want to expose all the details to the outside. So now let's define 3 public properties. Actually, to save time, I'm going to duplicate this a couple times. Now we want to expose start time, and here we want to return start time. Next, we want to expose end time. Here I'm going to use multi-cursor editing. Look, I've selected both duration instances and I'm going to replace them with end time. One more time. This time I'm going to expose running. Okay, now back to our prototype methods. So here I'm going to replace running with this dot running, and start time with this dot start time. I'm going to make the same changes to the other methods. So here in the stop method. All right, so here's what we have now. Now there is a tricky situation here. In the stop method and the last line, we're adding the seconds to the duration. Now duration is a public read-only property. So I cannot modify it like this because currently it doesn't have a setter. Now, if we go back to our stopwatch constructor here, we can define a setter for this to solve this problem, but this is going to lead to another problem. So let me add this first and then we'll talk about that. So setter, a function that takes a value, and here we simply set duration to this value. Now, back to the stop method. So we can access the duration property and update its value. Similarly, in the reset method, we can set this the duration. But this was a terrible idea. Why? Because I can create a stopwatch here, new stopwatch, and then simply modify this duration from the outside. This will completely mess up with the state of this object. Remember this principle. Your objects should always be in a valid state. You don't want your objects to lie. You don't want them to be unreliable and untrustworthy. That's why we use abstraction. With abstraction, we hide the unnecessary complexity and expose very few members that would allow the clients of an object to work with it without messing up its state. So I designed this exercise for you so you can see that sometimes you make some changes to your code for optimization reasons, but you end up creating many other issues. In this program, we didn't have any performance problems, and we knew that we are not going to have, let's say, 1,000 instances of the stopwatch in the memory. So putting all these methods on the prototype was a very bad idea to start with. It broke the abstraction principle, and now we're exposing this duration property so we can modify it from the outside. So essentially, this stopwatch object is now useless. There is a famous saying that says premature optimization is the root of all evils. And here we have a real example of premature optimization. So here we have a circle object with a radius property and two methods that are defined on its prototype. We have the draw method and the duplicate method. Now let's imagine tomorrow we're going to add a square object here, and that square object should also have a duplicate method with the exact same implementation. We don't want to repeat this implementation. In other words, we don't want to define a square constructor and then redefine the duplicate method on the prototype of this constructor. So square.prototype.duplicate, we don't want to do this, right? Instead, we want to use inheritance. So we can define a shape object and put this duplicate method there, and then have circle and square inherited from the shape object. So let me show you how to do this. First, I'm going to delete everything about a square, because once you learn how to inherit a circle from a shape, you can easily have square inherit from the shape object. So delete. Now let's define this shape constructor. Next, we want to move this duplicate method and put it on the prototype of the shape. So shape.prototype.duplicate. Okay? So to make sure we're on the same page, let's define two objects here. One is a shape and the other is a circle. New circle with radius of 1. Now back to the console. So here's our shape. It inherits from this object, which we call shape base. And in shape base, we have the duplicate method. And as you can see, shape base inherits from this object, which is our object base, the root of all objects in JavaScript. Okay? We have the exact same structure in our circle. Let's verify that. So we have a circle. Circle has a radius. It inherits from, let's call this circle base. In circle base, we have the draw method. And as you can see, circle base inherits from object base. So here's a visualization of what we have in memory. We have this C object, which inherits from circle base, which is essentially circle.prototype. And this circle base inherits from object base. Similarly, we have S, which inherits from shape base. And this is the same object referenced by shape.prototype. And this object inherits from object base. Now, to set up inheritance here, we want to have circle base inherit from shape base. How do we do this? It's really easy. In JavaScript, we have a method for creating an object with a given prototype. So object.create, look at the argument here. That's the object to use as a prototype. So we want a new circle base object that inherits from shape base instead of object base, right? Now shape base is shape.prototype, right? So here we pass shape.prototype, and this returns an object that inherits from shape base. Now all we have to do is to use this object as the prototype for our circles. So we reset circle.prototype to this new object. So before this line, our circle base or circle.prototype was like this. So circle.prototype was an object that inherited from object.prototype, which we call object base, right? So this was the implicit relationship. Now we change circle base or circle.prototype to a new object that inherits from shape.prototype or shape base, okay? So let's delete this line. Now save the changes back in the console. Let's look at what we have. So here's our shape. Shape inherits from shape base. Here we have the duplicate method, and shape base inherits from object base. So far, so good. Now let's take a look at the circle. So circle inherits from circle base. Now don't worry about this shape here. This doesn't mean that this is the shape object. This is a circle base object. What you see here is the parent for that object. Let me explain what I mean. So let's expand this. In circle base, we have the draw method. Perfect. Now circle base inherits from shape base, and that's why we have shape here. Let's look at the prototype. Look, this is shape base. We have the duplicate method, and shape base inherits from object base. So now with all this, the circle object has a draw method. It also has the duplicate method that it inherits from the shape object. So this is prototypical inheritance in action. Now there is a tiny problem with this implementation. Let me comment out this line and go back to the console. Earlier I told you that every object in JavaScript has a constructor property that returns the function that was used to construct or create that object. Let's take a look at our circle object. So this circle, look at its prototype. This is essentially circle.prototype, right? Now here we have this constructor property which references our circle function. Now with this, technically, we can create a circle object like this, circle.prototype that returns this object here, right? And here we have the constructor property, and this returns this circle constructor function, right? So technically we can new up this expression and pass a radius of 1, and this returns a circle object. So this expression is equivalent to new circle of 1. They're exactly the same. Now obviously we use this form because it's shorter and cleaner, but in some rare circumstances, you may get a constructor function somewhere in your application, and you may want to dynamically create an object based on that constructor function. So there you can access the prototype property, and from there you get the constructor and then use the new operator. Now let's see what happens when we uncomment this line. So back in the console, let's take a look at the circle one more time. So circle.prototype, look, we no longer have that constructor property here. So let's look at the prototype for this object. Here we have the constructor property, but this is returning the shape function, not the circle function. In other words, with what we have now, we no longer can create circle objects based on its constructor in a dynamic fashion. So if we get this circle constructor dynamically in a function and then try to access its prototype property and then the constructor and then new that up, look, we get a shape object, not a circle object. The reason we're having this problem is because we reset the prototype of the circle. Before this line, the prototype of the circle had this constructor property. So circle.prototype.constructor, this was set to the circle constructor. That's why we could new up a circle like this. This is exactly like newing up a circle object, right? So as a best practice, whenever you reset the prototype of an object, you should also reset the constructor. So here we should set circle.prototype.constructor. We should set that to the circle constructor function. Let's save the changes. Now let's inspect C one more time. So here's the prototype for the circle. You can see constructor is referencing the circle function. Beautiful. We have the draw method, which is part of the prototype for circles, and the rest is exactly like before. So this is shape base, or the prototype for shapes, where we have the duplicate method. Now we can new up a circle like this. So circle.prototype.constructor, pass 1 as the radius, and we get a circle object. So one more time, whenever you reset the prototype, as a best practice, make sure to reset the constructor as well. All right, now let's take this example to the next level. I'm going to modify the shape constructor and introduce a color parameter. We want every shape to have a color. So here we set this.color to color. Now with the current implementation, when we create a circle, we only pass the radius. So if we log C on the console, we can only see the radius property. There is no color here. But from an inheritance point of view, this circle object should have a color property, and that should be initialized at the time of creating a circle. How do we do this? Very easy. Here in the circle constructor, we should call the shape constructor. Now, one easy way to do this, which actually doesn't work, is like this. So we call shape, it's a function, right? We need to pass a color. So let's add the color parameter here and simply pass that to this shape function. Now, let's modify this line where we create a circle object and pass an argument for the color. Save the changes. Let's look at the circle. We don't have the color property. We only have the radius. Why didn't it work? Well, earlier I told you that when you use the new operator, 3 things happen. This new operator creates a new empty object and then sets this to point to that object. So here we set the radius property on that new object. And finally, that new object will be returned from this constructor, right? Also, I told you that if you don't use the new operator, this by default will point to the global object, which is window in the browser and global in Node. So the reason this didn't work is because, let me put this back here. Here we're calling the shape function, and by default, this in this function will point to the global object. So we didn't set the color property on the new instance of the circle object. We set it on the window object. Let's verify that. So window.color, look, it's red. So how do we fix this problem? We don't want to use the new operator here because this will create another new object and then set the color property on that object. We want to use the object that is referenced by this. So to fix this problem, we need to call the shape function and set this to point to the new instance of the circle object. Earlier I told you that every function in JavaScript is an object. So shape dot, this is the shape object with these properties and methods. You also learn about the call method. So we can call this shape function and look at the first argument of the call method, this arg. So the object to be used as the current object. Now here we can pass this, and this is the instance of the circle object. We're going to use the same instance here. All right. Now we pass our arguments. In this case, we want to pass the color argument, and this will solve the problem. Save the changes, back in the console, see, now our circle has 2 properties. So this is how you call the super constructor. So we have set up our inheritance chain properly. Now let's create another object, like a square that inherits from the shape. So that should be very easy. We create a constructor, square. It takes a size. We set the size. Now we want this square to inherit from the shape. So I'm going to copy these 2 lines for resetting the prototype here. And then change this to square and square. Of course, we need to change this one more time. Now with this, we can create a square object, new square with size 10. Let's inspect this. So we have the size property. Here's the prototype. We don't have any methods in the prototype for the square. Let's look at its parent prototype. So here we have the duplicate method that we inherited from the shape object. So we can call square.duplicate and everything works beautifully. However, these two lines for setting up the prototype chain is a little bit noisy. And as we define multiple objects, this logic gets in the way and chances are we might make a mistake along the way. So let's refactor this code and extract these two lines into a function that we can reuse. So here I'm going to define a function called extend that takes two parameters, child and parent. And note that here the first letter of these parameters is uppercase because I'm expecting these to be constructor functions. So now let's put these two lines inside this function and change circle to child and shape to parent. Now we have encapsulated this logic somewhere that we can reuse. So let's put this further up. I'm going to put it before the circle constructor. So we define a constructor and then we can call extend, pass circle and shape. We extend the circle with the shape. And then we can add other stuff in the prototype for circle. Now let's make the same change for our squares. So instead of these two lines here, right after we define the constructor function, we call extend square with shape. Save the changes. Let's make sure everything works. So let's define a square, new square, and then call duplicate. Beautiful. So this extend function is what we call intermediate function inheritance. I've simplified the code from the last lecture so we can focus on one concept. So let's see what we have here. We have our extend function. We have a very simple shape constructor. This shape has this duplicate method on its prototype. After that, we have the circle constructor. We have the circle inherit from the shape. And finally, we create a new circle object. So now if you go on the console and type c.duplicate, we get duplicate on the console. Now, sometimes as you work with inheritance, you may face a situation where this implementation that you have defined in a parent object may not work or may not be ideal in a child object. So let's imagine this algorithm for duplicating a shape works for most of the shape objects, but maybe it should behave differently for circle objects. What should we do? That's when we use method overriding. So we override a method that is defined in the base object. And it's very simple. All we have to do is to redefine this method in the circle object. So I'm going to copy this. Here we have the constructor. We extend it. Then after that, we redefine this on circle.prototype. It's very important to put this after extending the circle because at this point we are resetting the prototype. So if we define this before resetting the prototype, then this implementation is going to disappear. Okay, so let's put this back here. Now, in this new implementation, I'm going to change the message to duplicate circle. Save the changes, back in the console, c.duplicate. Note that we get the duplicate circle message. So the reason this worked goes back to how prototypical inheritance works in JavaScript. When we access a property or a method on an object, JavaScript engine walks up the prototype chain and picks the first implementation. So even though in this hierarchy, we have implemented the duplicate method both on the parent and child objects, the implementation on the child object will be used. Now, sometimes you may want to call the implementation on the parent object as well. Let me show you how to do this. So here, In circle.prototype.duplicate, let's imagine we're going to call the duplicate method on the parent or the shape object. If you're not using this in this implementation, we can simply call that like a regular function. So shape.prototype.duplicate, we call it like this. Now, if we're using this in this implementation, then we need to use the call method to set the context for this. So we call the call method and pass this as the context for the current object. So save the changes, back in the console, let's call c.duplicate. So first we get the duplicate message, which comes from the implementation of duplicate method in the shape object. And then after that, we have duplicate circle. So in the last lecture, you learned about method overriding, which basically means re-implementing a method in a child object. Now this brings us to a very important and powerful concept in object-oriented programming called polymorphism. Poly means many, morph means form. So polymorphism means many forms. It's an extremely powerful technique in object-oriented programming, as I'm going to show you in a second. So continuing from the example from the last lecture, I'm going to define a new shape object called square. So let's define a constructor square. Now, just like the circle, we want to have this square inherit from shape. So we extend square with shape. And then we're going to redefine this duplicate method on the square object. So square.prototype.duplicate. And then let's change this to duplicate square. So basically, what we have now is a simple hierarchy. On the top, we have the shape, and we have two derivatives or child objects, circle and shape. Each object will provide a different implementation of the duplicate method. So we have many implementations or many forms of the duplicate method. That's what we call polymorphism. Now, why is this so powerful? Let me show you. So let's imagine we have an array of shape objects. So let's define an array, constant, shapes. In this array, I'm going to add two objects, a circle and a square. Now we can iterate over this array using for of loop. So for, let shape of shapes, and then call shape.duplicate. Depending on the type of the shape object, a different implementation or a different form of the duplicate method will be called. So if shape is a circle, the implementation of duplicate in the circle object will be called. If it's a square, a different implementation will be called. Let's have a look. Save the changes, look in the console. Duplicate circle, duplicate square. Why is this so powerful? Well, before object-oriented programming, if we wanted to implement this logic, we would have to write code like this. So in this for loop, we would have to check the type of each object. Let's say shape, the type. If it's a circle, then perhaps we would have a function somewhere else, like duplicate circle. We would have to call that function. Now, this function is not part of any objects. It's just a standalone function. This is the non-object-oriented way of writing code. In object-oriented programming, we encapsulate our variables and functions into objects. Now, continuing with this implementation, then we would have to check else if shape.type is a square, then we would have to call a different function, duplicate square. And we could have another if statement, else duplicate shape. Now, this is a very simple program. What if we had 10 different types of shapes? We would end up with 11 conditional statements in this block. In contrast, when we encapsulate variables and functions into objects and use inheritance, we can execute many forms of a method using a single line of code. So instead of all this, it would call shape the duplicate. Isn't that beautiful? So that's polymorphism in action. So you have seen inheritance and polymorphism in action. While inheritance is a great tool for solving the problem of code reuse, you have to be really careful about using it because it can make your source code complex and fragile. So don't use inheritance just for the sake of using it, especially in small projects. As I've always emphasized in all my courses, keep it simple and stupid. Start with simple objects, and then if you see a number of these objects share similar features, then perhaps you can encapsulate those features inside of a generic object and use inheritance. But remember, inheritance is not the only solution to enable code reuse. There is another technique called composition, which you're going to learn about soon. So let's see the problem with inheritance. Here we have this animal object with two methods, eat and walk. And we have two objects that derive from animal, person and dog. Now, tomorrow we're going to introduce a new object called goldfish that derives from animal. Our hierarchy is broken. Why? Because goldfish cannot walk, it can swim. So we got the hierarchy wrong. And this is something that happens quite often, especially amongst inexperienced developers. So, to solve this problem, we need to change our hierarchy. On the top, we should have the animal object with the eat method. Under that, we're going to have two objects, mammal and fish. Mammals can walk, fish can swim. And then we can have person and dog derived from mammal, and goldfish derived from fish. See what happened? As a result of introducing a new kind of animal, that is goldfish, we had to change our hierarchy, and now this hierarchy is more complex than what we had before. Now, what would happen if we had 10 different types of animals? This hierarchy would get more and more complex, and we have to constantly go back and forth to determine the right place to implement a method. So, avoid creating inheritance hierarchies because they're very fragile. If you want to use inheritance, keep it to one level. Do not go more than one level of inheritance. There is a famous saying that says, favor composition over inheritance. With composition, instead of having a complex hierarchy like this, we can compose a few objects together to create a new object. And this technique gives us great flexibility. So, back to our previous example, instead of using inheritance, we can define various features for our animals as independent objects. So we can have three objects, like can walk, can eat, and can swim. Each of these objects are plain JavaScript objects with certain properties and methods. Now we want to have a person object, okay? We simply compose can walk and can eat to create a person object. Tomorrow we want to introduce a goldfish. Awesome. We can compose, can eat, and can swim together to produce a goldfish. So we don't have a hierarchy, and we can come up with any combination of these objects to create new objects. In JavaScript, we can use mixins to achieve composition, and that's what you're going to see in the next lecture. All right, let's start by defining a new object. Can eat. We use the object literal syntax, and in this object we add one method called eat. Now here we can reduce the hunger, so this.hunger minus minus, and do a simple console.log eating. So we're defining one feature as an object. Now similarly we can define another feature, so can walk. This time we're going to add the walk method and simply do a console.log walking. Now we can compose these objects together to create a person that can eat and walk. So in ES6 we have a new method that is object.assign, and we can use this to copy the properties and methods from one object to another. So we pass an empty object as the target and then pass one or more source objects. So If we pass can eat here, this object.assign will copy all the properties and methods that we have defined in can eat into this blank object. Now we can add more sources here. So we can add can walk as well. And with this, our empty object will end up being the combination of these two different objects. So let's store that in person and log it on the console. Now save the changes. So here's our person object with two methods, eat and walk. Now if we're using a constructor function, we can still use this technique. So let's define a constructor called person. Here we can add any properties and methods specific to person objects. And then after that, instead of passing an empty object as the first argument here, we can pass person.prototype as the target object. And we don't need the return value anymore. So we have basically modified the prototype of person and added the capability to eat and walk. Now, next time we create a person object, that person will have these capabilities. So new person, save. Now, here's our person object. In its prototype, we have the eat and walk methods. Now, let's say tomorrow we're going to add two new objects in this application, goldfish and duck. Both the goldfish and duck should have the capability to swim. So we can define a new feature, constant, can swim. And here we add the swim method. Very simple implementation, console.log swim. And then we can define a new constructor like goldfish and use object.assign to modify the prototype for goldfish. So goldfish.prototype. This time we're going to mix this object with can eat and can swim. So you can see composition or mix-ins gives us great flexibility. So now let's create a new goldfish object, constant goldfish. We set it to a new goldfish and then log it on the console. Goldfish. Okay, here's our goldfish. In its prototype, we have two methods, eat and swim. Now to make this code a bit more readable, we can extract this logic, this line, into a function called mixin. So on the top, let's define this function, mixin. We add the target object here, and we want to have one or more sources. Now we don't want to add multiple parameters here like source 1, source 2, because we don't know every time we want to use this function how many arguments we're going to pass here. So to solve this problem, we can use the rest operator in ES6. So we add only one parameter here, sources, and then use the rest operator, which is 3 dots, and this will collect all the arguments and turn them into an array. Now here we add object.assign. We pass the target. Now here, sources is an array, but object.assign needs sources explicitly. We cannot pass an array here. So this time we can use the spread operator to spread an array into multiple arguments. So the syntax is exactly the same, but this time we call this operator spread operator because we are spreading an array into multiple objects. So sources. Now with this new mixin function, we can simplify this code. Instead of using object.assign, we can say mixin person.prototype with can eat and can walk. And similarly, we can use mixin here. And the end result will be exactly the same. All right, now it's time for an exercise. I want you to design two objects. One is HTML element, and the other is HTML select element, which represents a drop-down list. We have prototypical inheritance between HTML select element and its parent, which is HTML element. Now see how these objects behave. I'm going to define a constant and set it to a new HTML element. Let's inspect this object. So in this object, we have one method, click. In its prototype, we have another method, focus. The implementation of these methods is very simple, just a console.log statement. What is important here is that we have one instance or own method and one prototype method. So start with this object, implement it, test it, make sure it works. So we can call e.click and we get this message, and e.focus, we get this message. Once you have HTML element, go ahead and create HTML select element. Let's see how that object behaves. So I'm going to define another constant, send it to a new HTML select element. Now here in the constructor, we can optionally pass an array of items, but we don't have to. If we don't pass anything here, it will be initialized to an empty array. Let's inspect this object. So here we have this items property, which is initialized to an empty array. We also have two methods, add item and remove item. I can call s.addItem and add one here. Let's add two as well. Now we remove two, remove item two. Let's inspect it one more time. So in this items array, we only have one item, one, okay? Now, what is important here is that this HTML select element inherits from HTML element. So let's look at its prototype. This prototype is an instance of HTML element object. Remember, our HTML element objects have two methods. One is click, which is an instance or own method, and the other is focus, which is a prototype method. So this is the tricky part of this exercise. I want you to pay great attention to this part. So do not use the extend function that we created earlier in this section. I want you to manually set the prototype for HTML select element. You should set that to an instance of the HTML element object because the click method is on the instance. If you set the prototype of HTML select element to the prototype of HTML element, you would only get the focus method because this is defined on the prototype. So go ahead, spend about 20 to maximum 30 minutes on this exercise, and next you will see my solution. All right, now let's take a look at my solution. So here we have this HTML element constructor function. We have a simple method here, click. We also have this focus method, which is defined on the prototype of HTML element. So this is our parent object. Now below that, we have another constructor, HTML select element. Note that I have initialized this items parameter to an empty array. This is something that we can do in ES6. Before ES6, we had to do something like this. So if items is defined, we would use that. Otherwise, we would use an empty array. Now with ES6, we can initialize the parameter, so this syntax is cleaner. So we set the items array here. We also have two methods, add item and remove item. The implementations are pretty straightforward. So in add item, I simply push an item to this array. And in remove item, I simply use the splice method to delete an item at the given position. This is just basic JavaScript. Now let's look at the important and tricky part of this exercise. That's the tricky part. We set the prototype of this HTML select element to an instance of an HTML element object. Earlier in this section, we used a different approach. So we use object.create and passed, let's say, HTML element.prototype. But this will not work in the current implementation. Let me explain why. Here, object.create will create a new object and set the prototype of that object to the prototype of HTML element. For discussion's sake, let's call the prototype of HTML element as base HTML element. So this is an object that has only one method. Look, here is the prototype of HTML element. It's an object with only one method, focus. So click is not there, right? So when we use object.create, we create a new object, and the prototype of that object would be base HTML element, which has the focus method. Now we can call this object that is returned here, let's call that base HTML select element. So when we create an instance of HTML select element, its prototype will be base HTML select element, which is an empty object that is linked to base HTML element as its prototype. Let's have a look at this on the console. So I'm going to create an HTML select element. Let's inspect this. So here's the prototype. This is an empty object. This is an empty object that is returned from object.create. Okay. Now object.create uses what we pass here as the prototype for that object. In this case, the prototype is base HTML element or HTML element.prototype, which is an object with a single method, focus, right? So back in the console, here the prototype of HTML select element is an empty object. It doesn't have anything, but its prototype is the prototype of HTML element, where we have the focus method, okay? So with this implementation, we don't inherit the click method in HTML select element. Now, to fix this, instead of using object.create to create an empty object that has HTML element.prototype as its prototype, we need to new up an HTML element object, because in this object we have the click method. And this object has its own prototype where we have defined the focus method, right? Now, let me remove these comments. Let's go back in the console, create another HTML select element. So now here's the prototype. This is an instance of HTML element object. We have the click method, and in the prototype we have the focus method. So with this, we can click a select element. We can also focus it. Now technically here, I should also have set the constructor. So HTML select element.prototype.constructor. We set this to HTML select element. Why did I set it to HTML select element? Because I told you that this expression is kind of similar to new HTML select element. So we can create an instance of HTML select element like this, or like this, new HTML select element.prototype.constructor. Obviously, we're not going to use this former approach, but in your applications, if you have a function where you get a constructor dynamically, and you want to create an instance of an object based on that constructor, then you have to reset the constructor property. Now, in the next section, when we get to ES6, you will see that implementing inheritance is far easier in ES6. You don't have to worry about this complexity, okay? So that brings us to the end of this exercise. All right, now the second exercise. Continuing from the last exercise, I want you to extend HTML select element and implement a render method. So here I'm going to define an HTML select element and initialize it with an array of 3 items. Now s.render, this is what we get. A select element with 3 options. Now similarly, I want you to create an HTML image element that inherits from HTML element. So it can be clicked, it can be focused, but it also has its own render method. So let's create an image here, new HTML image element. Now here we can optionally pass the source or the address of the image. I'm not going to set that yet. Let's inspect this element. So here we have a source property which is undefined and the render method. You can see its prototype So it inherits from an instance of HTML element. It has the click method as well as the focus method. So now I'm going to set image.source to HTTP, whatever, it doesn't really matter, and call image.render. So we get an image element in HTML. Once you do this, then I want you to create an array of elements. So here we have one select element and one image element. Then iterate over this array of elements and render them each. Note that here, my render method is returning a string. It's not doing a console.log. It's not the responsibility of this object. We don't want to couple this render method with console.log. We just want the HTML representation of an element, and somewhere else we decide what to do with that HTML representation. Maybe we want to add it to document object model, or maybe we want to log it on the console. That's why we shouldn't use console.log inside of the render method. So this is your polymorphism exercise. We have different objects, they all have the same parent, they all have a render method, but the render method behaves differently. We have different forms or multiple forms of the render method. That's what we call polymorphism. So save the changes back in the console. That's what you should get. So here's my implementation of the HTML image element object. We have this constructor that receives a source parameter. Here we set the source property, and we also define the render method. Note that here, to return this HTML markup, I'm using a template string. So instead of a single or a double quote, I'm using the backtick character, which is the character before number 1 on your keyboard. So this is part of ES6, and it allows us to pass arguments to this string. So here, note that I have this argument indicated by a $sign and curly braces. So what we have inside of these curly braces, in this case, this.source, will be dynamically placed into this string at runtime. This is much cleaner than code like this. Return image source, then we concatenate this with this.source, then concatenate again. Now here I have to remember that I used single quote, so I add double quote to terminate this source attribute, and then add a slash and angle brackets. Look, this is really ugly. So use template strings in ES6, that's much cleaner. And to pass arguments, use a $sign and curly braces. Then whatever you put here will be placed into the string at runtime. Now, there is a more advanced version of a template string I'm going to show you in a second. So let's go to our HTML select element object. This is the other render method. So here we're returning a template string. Inside of this template string, we have the select element, but we want to render multiple option elements. See how we can achieve this, how we can add a loop inside of a template string. So note that here I have an argument, right? Here I'm referencing this.items, which is our array of items. I'm using the map method in ES6, so we can get each item in this array and map or convert it to something else. So here this map method takes an arrow function, which is again another new feature in ES6. So in case you're not familiar with arrow functions, this is how they work. Let's imagine I have a function that takes an item and returns a template string like this. So I get the item and convert it to a string with option and slash option. And in the middle, I'm going to add an argument where I render the item, right? Oops, I forgot to name this function. Let's use a function expression. So I'm going to define a constant called render item and set it to this function expression, right? Now we can rewrite this function in a shorter and cleaner way using an arrow function. So we get rid of the function keyword. We add the parameters here, and to separate them from the body of the function, we use a fat arrow. Now, if we have only a single parameter, we can also remove the parentheses. And if we have a single return statement here, we can make this code even shorter. We can get rid of the return keyword as well as the curly braces. So put everything in one line. This is what we call an arrow function. We take an item and map it to a string like this. Now, I have used this inside of my template string here. So here after the select element, I have an argument in the template string. Inside this argument, I have this expression, this.items.map. So I'm calling the map method on the array. And as an argument, I'm passing an arrow function. Item goes to this template string. So we can have a template string inside of another template string. Now in this template string, we have option, item, and option. This is exactly what we have here. Now, this is the end of the map method. Map basically returns an array. So we get an array of items and map them to another array. That's an array of strings, options, right? Now, we want to combine all the elements in this array using an empty string. If we don't use the join method here, when this array is converted to a string, we will end up getting a comma after each option. So to solve that problem, we combine all the elements in the array using an empty string. Okay? So that's a more advanced usage of the template strings in ES6. I hope you enjoyed this lecture and thank you for watching. Over the last few sections, we learned all about objects and prototypical inheritance in JavaScript. Now in ES6 or ES 2015, which is like the modern version of JavaScript, there is a new way to create objects and implement inheritance. That's using classes. But these classes are not like classes that we have in languages like C# and Java. They're essentially syntactic sugar over prototypical inheritance. That's why I wanted to make sure that you fully understand how prototypical inheritance works before we look at the new syntax, which is cleaner and simpler. So here we have this constructor function that you have seen throughout the course. We have this radius property as well as the draw method. Now let's see how we can rewrite this code using ES6 classes. So for now, I'm going to comment out this code. So we create a class with the same name. We start with the class keyword, add the name of the class, and then curly braces. This is what we call the body of this class. In this body, we can define properties and methods. One special method that we have, it's called constructor, and we use that to initialize objects, just like this constructor function that we have here. So in this method, we pass the radius parameter and set the radius property on the new object instance that is created. So that's our radius property. Now, if you want to define a method, we won't use this syntax. That's not how we do it. Instead, we define methods in the body of this class. So here we add the draw method like this. So note that we don't have the function keyword here. We just add the name of the method and parentheses and then curly braces. So this syntax is more familiar to people who come from languages like C# and Java. But as I told you before, these classes are just syntactic sugar over constructor functions. And you're going to see that in a second. So in this method, let's do a console.log. Now we can create circle objects just like before. So const C, we set this to a new circle. Of course, here we need to pass the radius. Done. Now here in the console, let's inspect C. So we have a circle object with the radius property. In its prototype, we have the draw method. So all the methods that we add here will end up on the prototype of the circle object. Now, if you don't want a method to end up on the prototype, then you need to define it in the constructor, just like before. So here I'm going to define a move method. Save the changes. Now let's inspect C. So here we have the move method on the object instance and the draw method on the prototype. So that's our circle object. Now let's look at the type of circle class. That's a function. So that's why I said these classes are essentially functions. They're constructor functions. Don't believe me? Let me show you. So if you head over to babel.js.io, you can see Babel. Babel is a JavaScript compiler. We give it our modern JavaScript code, and it compiles it down to ES5 code that all browsers understand. So you can type some modern JavaScript code here, and then see the result of compilation in ES5 below. So let's just define a circle class here, add a constructor that takes a radius and sets this.radius to this radius argument, okay? Now, here is the result of compilation. So we have this circle constructor function. Look, it's a function that takes radius. Now, don't worry about what we have on the first line. I'm going to get to that in a second. But if you scroll down, you can see this.radius is set to radius. That's exactly like what we had in our constructor functions. Now, what is this first line here? Well, here we have a function called class call check. And the job of this function is to make sure that you have used the new operator. If you don't, it's going to yell at you. Let me show you. So back to our code here. If I forget to use the new operator, look, we get this error. Class constructor circle cannot be invoked without new. So earlier in the course where I talked about factory and constructor functions, I told you that one of the arguments that people make against constructor functions is that the developer has to remember to use the new operator. Now, personally, I don't really like this argument. It's very childish. If a programmer forgets to use the new operator, what kind of programmer are they? But anyway, let's just stick to that. Classes in ES6 enforce the use of the new operator. So that argument about the new operator, in my opinion, is no longer valid. Now, later in this section, when we get to inheritance, you will see that classes provide a cleaner syntax to implement inheritance than what you learned in the last section about prototypical inheritance. So that's the basic of classes. Over the next few lectures, we're going to look at classes in more detail. In this lecture, I'm going to talk about hoisting. So in JavaScript, there are two ways to define functions. We can use the function declaration syntax, which is like this. Function say hello. Or we can use the function expression syntax. So we define a variable or a constant. Let's call it say goodbye and set it to a function. So this is what we call a function expression. Now, by convention, with function expressions, we should add the semicolon at the end, but with function declarations, we don't add the semicolon here. The reason for that is, let's say here we're going to define a number, set it to 1. Here, because we're dealing with an expression, we put a semicolon at the end. So on both lines 6 and 7, we're dealing with expressions, and that's why we terminate them with a semicolon. Now, semicolon aside, there is a critical difference between a function declaration and a function expression in JavaScript. Function declarations are hoisted, which means they're raised to the top of the code. So I can declare this function here and then call it before its declaration. So here we can call say hello, and that's perfectly valid. So look, we don't get any errors in the console because this function is hoisted, which means raised to the top. So essentially when this code is executed, it looks like this, okay? In contrast, function expressions are not hoisted. So here, if I call say goodbye, I'm going to get an error. And here's the error. Say goodbye is not defined. Again, because here we're dealing with an expression, we're dealing with a constant or a variable that is not initialized. So if I define, let's say, a constant called number and set it to 1 here, what would happen if we do a console.log of number? We're going to get the same error. Number is not defined. So here the only difference between number and say goodbye is that number is a primitive, say goodbye is a function, or more accurately is an object. So we cannot use these identifiers before they're declared. So function expressions are not hoisted, okay? Now, when it comes to classes, we can define classes using a declaration or an expression syntax. So let me clear this up. We can define a class like this, class circle. And this is what we call class declaration, which is what you saw in the last lecture. Alternatively, we can use a class expression. So we define, let's say, a constant called square, set it to a class with no name. So this is what we call class expression. Now, unlike functions, class declarations or class expressions are not hoisted. So here I cannot create a circle object like this. It's going to give me this error. Class is not defined. That's because this class declaration is not hoisted or raised to the top. So if you hear hoisting somewhere, that's the meaning of hoisting. Now, which syntax should you use? A class declaration or class expression? Personally, I have not seen a use case for using a class expression. Pretty much everyone uses the class declaration syntax. So stick to that because that's simpler and cleaner. In classical object-oriented languages, we have two types of methods, instance methods and static methods. So let's see what is the difference. In this example, this draw method is what we call an instance method, because this method is available on an instance of a class, which is an object. So if we create a circle object here, new circle with radius 1, and log it on the console. So in the circle object, on this instance, we have the draw method. In contrast, we have static methods. Static methods are available on the class itself, not the object instance. We often use them to create utility functions that are not specific to a given object. For example, in the circle class, this draw is specific to a circle object. It's a particular circle object that we want to draw, right? So that's why it's an instance method. But here I can define a static method that is not tied to a particular circle object. Let's call that parse. So a parse takes a string, which is supposed to be a JSON string. It will parse it and return a new circle object. Now, to make this static, we use the static keyword on the front. And with this method will no longer be available on a circle object. So here we won't have circle.parse. It doesn't exist. Let me show you. So here in the console, circle has a radius and the draw method. The parse method is not here, but it's accessible on the class reference. So circle.parse, it's here. So with this method, we're not working with a particular circle object. We're working with the circle class itself. So to call static methods, we don't have to create an instance of a class. Now let's go ahead and implement this method. So here I'm going to use JSON.parse to parse this string. Here we get the JSON object. Assuming that this is a valid JSON object and it has a radius property, we can get that, store it in a constant, and then new up a circle object with that radius and return it. Now with this method, we don't have to create a circle object first because we don't have a circle object to start with. We have a JSON string. So we call circle.parse and pass a valid JSON object here with this key, radius. And we set the value to 1. Now this static method returns a circle object. Let's test this. So save, and here's our circle object on the console. So one more time, we use static methods to create utility functions that are not tied to a particular object. Let me show you another example. In JavaScript, we have this built-in object, math, and this object gives us a bunch of utility methods, right? Now here we're not newing up a math object. We're not doing something like this. We directly access these methods on the math object itself. So here math looks like a class. If this math object didn't exist in JavaScript and we wanted to implement it using ES6 classes, this is how we would do it. So we would define a class called math and define a bunch of static methods like ABS or absolute, which takes a value and does some magic here. We don't care about that. Then we could access this method directly on the math class itself. Now this is clashing with the built-in object in JavaScript. So let me rename this to math2. Now look, math2 dot, we have this ABS method here. So again, in this example, we're not working with a particular object. This absolute is a utility function that takes an input and returns something. In this lecture, we're going to have a closer look at the this keyword in JavaScript. So I'm going to start by declaring a constructor function called circle. And in this constructor function, I'm going to set this.draw to a function. We simply do a console.log of this. Now we create a circle object. So constant C, we set it to a new circle and then call c.draw. Now, when I save the changes on the console, you're going to see our circle object because this will point to that circle object. So let's see, save the changes, and here is our circle object, right? Now let me show you something interesting. Instead of calling this draw method like this, I'm going to get a reference to this method, store it in this constant called draw, so c.draw. Note that I'm not calling this method. I'm simply getting a reference to this method. So if we do a console.log of draw, we're going to see this function. Let's take a look. Save the changes, and here's our draw function, right? Now, I'm going to call this draw function like this. Now, when I save the changes, instead of seeing the circle object, you're going to see the window object. Let me show you. So save. And here's our window object. But what happened here? Why didn't we get the circle object? Okay, let me tell you why. First of all, this syntax we have on line 7 is what we call method call. Because we're calling a method on an object, right? In this case, this in this function will point to this object, which is our circle object, right? Now, the syntax we have on line 11 is what we call function call. Because we're calling this like a standalone function that is not part of an object. So when we call this method as a function, by default, this will point to the global object, which is window in the browser and global in Node. Now to refresh your memory, earlier in the course, I told you that here when we use the new operator, this new operator will create a new empty object and set this in this constructor function to point to that object. And I also told you that if you forget to use the new operator, this by default will point to the global object, which is window in the browser or global in Node. We have exactly the same principle here. So when we call draw as a method on an object, this will point to that object. And if we call this method as a standalone function, this will point to the global object. Now, in JavaScript, we have this mode that is called strict mode. When we enable this mode, JavaScript engine will be more sensitive. So it will do more error checking. If there are errors that silently fail, it's going to turn them into exceptions. And also it will change the behavior of the this keyword in functions. So we can enable the strict mode by adding this string on the top, use strict. Now, when I save the changes, you will see that instead of getting the window object here, we'll get undefined. So save, here it is, undefined. So when we enable strict mode, if we call a method as a function, this by default will no longer point to the global object, it will be set to undefined. And the reason for this is to prevent us from accidentally modifying the global object, because that's bad practice. Now, there's more to this strict mode that is beyond the scope of this course, but let's see how this keyword behaves in our ES6 classes. So I'm going to delete all this code and define a circle class. Here we add the draw method and do a console.log of this. Now we create an object, circle, get a reference to the draw method, So c.draw, and then call it like a function. What do you think we're going to see? Let's have a look. Save the changes, we get undefined. Because by default, the body of our classes are executed in the strict mode. So whether we explicitly enable the strict mode on top of this file or not, JavaScript engine will execute the body of this class in the strict mode. And this will prevent us from accidentally modifying the global object. Earlier in the course, I talked about abstraction as one of the core principles of object-oriented programming. So abstraction means hiding the details and complexity and showing only the essential parts. Remember the DVD player? That's abstraction. Now, to implement abstraction, we use private properties and methods. So we hide certain members of an object so they won't be accessible from the outside. So here we have this circle class. We set the radius property in the constructor. And as you know, this radius property is public by default, which means if I create a circle object, pass 1 as the radius, then I can access this radius property here. Now in this case, we want the radius to be public because that's an essential attribute about a circle. But in this lecture, let's imagine we want this radius property to be private. So I'm going to show you how to implement private properties and methods when using ES6 classes. There are basically 3 different approaches, but the first approach, in my opinion, is a terrible approach, so I don't even count that. The first approach is using an underscore as a naming convention. So some developers name their private properties or methods using an underscore. So they prefix it with an underscore like this, and then they assume that this is a private property. Why do I say this is a terrible approach? Because I can still access this radius from the outside. So this is not abstraction. This is a convention for developers. It doesn't prevent another developer from writing code against this property. As I told you before, with abstraction, we want to hide some of these properties and methods from the outside. So as we change them, we isolate the impact of changes to the containing object. We don't want these details to leak to the outside, right? So this is not a way to implement private properties and methods. Please do not use this approach. Now in this lecture, I'm going to show you how to use ES6 symbols to implement private properties and methods. And in the next lecture, I'm going to show you how to use maps to achieve the same thing. So in ES6, we have a new type, a primitive type called symbol. Remember primitives? We have number, string, boolean. Now we have another primitive called symbol. So I'm going to define a constant called underline radius and set it to a symbol. So symbol is a function we call to generate a symbol. A symbol is essentially a unique identifier. Every time we call this function, we get a new unique identifier. And note that this is not a constructor function, so we cannot new that up, otherwise we get an error. So here in the console, I'm going to create one symbol and compare it with another symbol. Look, they're not the same. So every time we call the symbol function, we get a new unique value. And we can use this unique value as the property name for an object. What do I mean by that? Well, back to our constructor. Let me revert this back to radius. Okay, so you know that in JavaScript, there are 2 ways to access a property in an object. We can use the dot notation, like what we have here, or brackets. So this, we pass a string, radius, and we set it to this argument. So these 2 lines are exactly the same. Now, with the introduction of symbols, we can also use a symbol as a property name instead of a string. So here we can use this, square brackets, underline radius, our symbol, right? And set it to the radius argument. Now I'm going to delete these 2 first lines. Let's see the impact of this change. So save the changes. Now we have a circle object. Let's log it on the console. So look at the property. It's called symbol. Now this is just how we see it internally. The name of the property is a unique value. So if we set multiple properties using symbols, the property names all will show up as symbol, but internally they are unique. Now you might say, but Mosh, this is not private because we still have this property here. Well, yes and no. Let me explain. So if I type C dot, look, we don't have that radius property anymore. We don't have underline radius, so we cannot directly access that property in code. There is a hack around that. Let me show you. So we have this method object that get own property names. We have seen this before. So let's do a console.log, call this method and pass C as an argument. We get an empty array because we don't have any properties, or more accurately, any regular properties in this object. But we have another method, get own property symbols instead of names. Now look at this. So this returns an array of symbols. I can get the first symbol. Let's store that in a constant called key. So this returns an array. I'm going to get the first element. This is just for demonstration, not something you should do. Now we have a key, so we can access C of key and then log it on the console. Then we get the value of the radius property. But we're not going to write code like that to access these kind of private properties. This is kind of awkward, right? So we can use symbols as a simple way to implement kind of private properties and methods. Now, how do we implement a private method? Well, earlier you learned that we can add a method here like draw. Now, to make this private, similarly, we can define another symbol. Let's call that draw. We set this to a new symbol. Now, instead of using this name here, we want to use our symbol. Now, in ES6, we have this new feature called computed property names. So we can add brackets, and inside of these brackets, we add an expression. When that expression is evaluated, the resulting value will be used as the name of a property or method. So here we pass underline draw. So this expression, our symbol, will be evaluated. We get a unique value, a unique identifier, and because we have put that inside of these brackets, that unique identifier will be used as the name of this method. So I'm going to save the changes. Let's log C on the console one more time. So we have this property, which is the radius property. And in the prototype where all these methods end up, we have another property. Look, that's our symbol. And that's set to a function. So that's our draw function, or more accurately, the draw method. In the next lecture, I'm going to show you how to use maps to implement private properties and methods. In this lecture, I'm going to show you how to use weak maps, which is a new type in ES6, to implement private properties and methods in an object. So continuing with our circle example, we want to turn this radius property into a private property. On the top, we're going to define a constant. We call it underline radius. That's just for our own convention to indicate that this is a private property. We set this to a new weak map. A weak map is essentially a dictionary where keys are objects and values can be anything. And the reason we call them weak maps is because the keys are weak. So if there are no references to these keys, there will be garbage collected. Now, inside of this constructor, we're not going to set the radius property anymore. Instead, we're going to work with this radius key map. We call the set method. The first argument is the key. And you can see that the key has to be an object. It cannot be a symbol. So here we pass this, which represents the instance of circle object. That's our key. And for the value, I'm going to use this radius argument. Now, technically, we can access this radius private property if we can get access to this weak map. But later, I'm going to talk about modules, and you will see that we can hide this radius in a module and only export the circle class. So imagine somewhere else in the code, we get the circle class. We won't have access to this weak map. And the circle object doesn't have a radius property, right? Let's inspect this on the console. So save, see, this is our circle object. Look, we don't have the radius property. Now, if you want to access this property inside of this class, we can do something like this. Let's imagine we want to read this somewhere. So I'm going to add our draw method. In order to read the radius property, we use our weak map, radius. Now, instead of calling the set method, we call the get method. We need to reference a key. In this case, the key is the instance of the circle object, this. And this will return the value of the radius property. So let's log that on the console. Now we can call c.draw and we get 1. Now how about defining a private method? We use another key map. So back here, I'm going to define another constant. Let's call this move and set it to a new weak map. Once again, in the constructor, we initialize this. So move.set, we pass this as the key and a function as the value. So here's a function. This is our move function, which is going to be a private function. Now here I'm going to do a console.log move, so we know we are in the move method. And also I want to add this, so you will see what this means in this context. Now let's imagine in our draw method, which is a public method, we want to call the move method, which is a private method. Now, I know this is not a good example because when drawing something, we don't want to move it. But let's just imagine this is part of the implementation detail. So in order to access this move function, we use the same technique we used here. So I'm going to delete this. We use underline move key map, call the get method and pass this. Now this returns a function, so we can call that function. Okay. And then we do a console.log of draw. Let's see what we get on the console. So save the changes. Now here we call c.draw. We got the message from the move method, but this is undefined because I told you that the body of this class is executed in strict mode, and this by default will be set to undefined as opposed to the global object. Now, in this particular implementation, maybe in the move method, we want to access the instance of the circle object. So how can we do this? Well, instead of using a regular function, we can use an arrow function, and the problem will go away because arrow functions use this value of their containing function. So in this case, this is not going to be rebound. It's going to be inherited from what we have in this constructor. So in this constructor, this references a circle object. And when we use an arrow function inside of this function, this will not be rebound. It's not going to be reset. It will be inherited from the constructor function. Okay. So let's save the changes. Call c.draw. Now we have the message from the move method, and here's our circle instance. So we can access all the public and private properties of the circle object in the move method. Now, one part you might be confused about is why we're using a separate weak map for each property or method. Why don't we create just one weak map for all the private members? Something like this. So constant private props, we set it to new weak map. And then here in the constructor, we could do something like this. Private props that set this. Now here we pass an object, and in this object we add all the private properties and methods. So we can add the radius property and set it to this radius argument. We could also add the move method. We use an arrow function here, and so on. Personally, I don't like this syntax. I think it's a little bit polluted. I prefer to work with each private member independently, but if you prefer this former syntax, by all means go for it. Just remember that if you use a single weak map, then in order to access, let's say, the radius property, you would do something like this. Private props that get this. Now this returns an object That's this object here, right? Now this object has the radius property, then you can access that here. Personally, I don't like this approach. So my preference is to use a separate weak map for each private member, like this. So I've simplified the example from the last lecture. Here we only have one private property, that is the radius property. Now, earlier in the course, I talked about getters and setters. So here we have defined a private property, but maybe we want to read this value from the outside. Perhaps we don't want to set it, we just want to read it. One way is to define a method like getRadius, and here we return underline radius that get, we pass this as the key, and then in the console we can call c.getRadius to read that value. But I don't like that here we're calling a method. It would be nicer if we could read that like a property. Okay, so earlier in the course where we talked about constructor functions, you saw that there we used object that define property to define a getter. So we passed an object like this, set the name of the property like radius, then passed another object, and here we added the get method like this. Now this syntax is very convoluted. In ES6 we can create a getter and setter much easier. So let's delete this. Now to implement a getter, we change the name of this method to radius so it looks like a property, and then simply add the get keyword on the front. It looks like a method, but actually we can access it like a property. Have a look. So save the changes. Now we can read the radius like this. We can also define a setter very easily. So we add a setter, radius, takes a value. Now here we can do some validation. So if value is less than or equal to 0, we're going to throw a new error, invalid radius. Otherwise, we need to set this radius private property. So just like how we set it in the constructor, we access our weak map called the set method, pass this, and then the new value. Let's test this. So here in the console, our circle initially has the radius of 1. We can reset it to 10. Let's read it again. Beautiful. Now if I change this to, let's say, -1, we get this error. And if you read it, the value is not changed. So you can see implementing getters and setters is far easier with ES6 classes. All right, now that we have learned all about classes in ES6, let's see how we can implement inheritance. So I'm going to start by declaring a class called shape. In this class, we add a method called move. Simply log this on the console. Now let's define a circle. So class circle. Now to have the circle inherit from the shape class, all we have to do is to add extends shape. So we don't have to reset the prototype, we don't have to reset the constructor. It's far easier and cleaner. Now here in the circle, we can add a draw method, console.log draw. Now let's create a circle object. So constant c, we set this to a new circle, and then inspect it in the console. So here's our circle object. Note that in its prototype, we have the draw method, because as I told you before, all the methods we implement here will end up in the prototype for circle. Now this prototype object itself has a prototype. Let's look at that. This is where we have the move method. Note the constructor property here. So this object was created by the shape class, and here this object was created by the circle class. So you can see with the extends keyword, we don't have to reset the constructor. It's far easier. So now our circle object can be moved and drawn. So we can call c.move, beautiful, and c.draw, sweet. Now let's take this to the next level. Let's imagine all our shapes need a color. So I'm going to add a constructor here. Constructor. Here we pass color and set the color property. Okay. Now if I save the changes, we don't get any errors. However, if we add a constructor in the circle class, let's see what happens. So we got an exception. Must call super constructor in derived class before accessing this or returning from derived constructor. So here's what's happening here. If you have a constructor in the parent class, and then you add a constructor in the derived class, inside of this constructor, you should make sure to call this constructor first to initialize this base object. Okay, so here in the constructor, we can use this super keyword to reference the parent object. So to call the constructor, we call this like a function, and here we pass the color argument. Now I'm going to change the constructor for the circle to pass the color. We get that and simply pass it to the super constructor. Save the changes. Now let's inspect C. Okay, our color is undefined because here, when creating a new circle, I forgot to pass the color. So let's say red. Now let's inspect this one more time. So here we have a red circle, beautiful. We can add additional properties here like radius and then set them here. This.radius to radius. Let's inspect C one more time. Once again, I forgot to pass the radius argument. So here on line 23, I'm going to pass 1 as the radius. And finally, we have a circle with these two properties, color and radius. We inherited color from our parent class, the shape class, and we added radius on the circle class itself. Earlier in the section about prototypical inheritance, I talked about method overriding. So method overriding is when we have a method in a base class or a base object, but we want to change its implementation in a derived class or a derived object. So maybe the algorithm for moving a shape is common amongst most of the shapes, but perhaps our circles need a different algorithm to be moved. So here we can override this move method by re-implementing it in the circle class. So we add the move method here. Let's do a console.log circle move to differentiate from the base implementation. Now, here we have a circle object. If we call c.move, you can see the implementation in the child object is used. And the reason for that goes back to our prototypical inheritance. So if you look at the C object here, in its prototype, we have the move method. This is the move method that we implemented here. So when we access c.move, JavaScript engine first looks for this method on the circle object itself. That is the object we have here. Now in this object, we don't have the move method. So then the JavaScript engine looks at the prototype for this object. So it looks here and it finds the move method here. Now note that this object has its own prototype. And in this prototype, we have another move method. That is the move method we implemented in the shape class. Now, when accessing a property or a method, because the JavaScript engine walks up this tree from the child all the way to the parent, this move method will be accessible first. That's why this implementation is used. Now, let's imagine you have a scenario where you want to reuse some of the code that you have implemented in the parent move method. In that case, you can call that by using the super keyword. So we can access the base object using super dot, and here's a move method. Now save the changes. So when we call c.move, so we get two messages, move that is coming from our shape class and circle move, which is coming from the circle class. So this is all about method overriding. All right, now it's time for an exercise. I want you to implement a stack using ES6 classes. What is a stack? A stack is a special kind of data structure like a physical stack or pile. It's one of those topics that you learn at university in your data structure subject. Unfortunately, there are a lot of developers out there who can build applications with Angular, React, Node, and whatnot, but they don't know the fundamentals of algorithms and data structures. That's why I'm planning to create a comprehensive course on this topic. So if you want to learn from me, be sure to keep an eye on my website and enroll in the course when it's ready. So let's see how a stack works. So look at this box we have here. A stack has two essential operations: push for adding an object in this box, and pop to remove the object on top of this box. So we can call the push method and push A, and now A is in the stack. Next we can push B, and now we have B, and similarly we can push C, and now we have C on top of this stack. Now, unlike arrays, we cannot access objects in a stack using their index, but we can always remove the object on top of the stack by calling the pop method. So we can call the pop method and C will pop out of the stack. Similarly, if we call the pop method again, B will pop out. So let's see this in action. I've implemented the stack class, so let's create a stack object, new stack. All right, have a look at this object. So here we have a count property. Currently we have 0 items in the stack. On the prototype we have 3 methods: peek, pop, and push. Peek is similar to pop. It returns the object on top of the stack, but it does not remove it from the stack. It only shows you what is on top of the stack. So let's see these methods in action. Stack.push, I'm going to push A. Stack.push, this time B, and finally C. So C is on top of the stack. Now if you look at the count property, you can see we have 3 objects in this stack. So to remove the object on the top, stack.pop, it returns C. And if you look at count, now we have 2 objects in the stack. Now if we call the peek method, it tells us that B is on top of the stack, but it doesn't remove it. So if we look at the count property one more time, we still have 2 objects on the stack. So let's call pop a couple more times. Now we removed A. So if you read the count property one more time, we have 0 items. Now let's see what happens if we call the pop method on an empty stack. So stack.pop, that's an invalid operation. So your code should throw an exception. Stack is empty. The same is true for the peek method. So if we call peek on an empty stack, again, we get the same error. So I want you to implement this data structure using ES6 classes. Next, you will see my solution. All right, now let's implement a stack class. So class stack. Now internally, I'm going to use an array to store the objects in this stack, but I want to keep that array private. I don't want it to be accessible from the outside because I want the consumers of the stack to only use the push and pop methods. If they have access to that internal array, they can always access the objects in the stack using their index. But as I told you before, in a stack, we should not be able to access objects using their index. Now, if this sounds confusing to you, you really need to take a course on data structures and algorithms. And as I told you before, I'm planning to create a course on this topic in the near future. So here I'm going to add a constructor to initialize that internal or private array. To implement a private property, I'm going to use a weak map. So on the top, let's define a constant called underline items and set it to a new weak map. Now here in the constructor, we're going to add an empty array in this weak map. So underline items.set, the key is this object and the value is an empty array. So later we'll use the get method to get access to this array to add objects to it. Okay, so now let's add the push method. Here we passed an object. Now we need access to this array here. So we call items.get, pass this. Now we have the array, so we call the push method And this will always add an object to the end of the array. So object. Very simple, one line of code. Now the pop method. We don't have any arguments here. First, we need to check if the stack is empty or not. So if, one more time, underline items that get this, that length is 0, we're going to throw a new error. Stack is empty. Otherwise, we should remove this object from the top of the stack. So underline items that get this. Now we have the array. All arrays in JavaScript also have a pop method that removes the object at the end of the array. So we call that and simply return the result. Now to remove this duplication, we can refactor this code and store this array in a constant in this method. So let's add a constant called items, and we set this to this expression here. And this simplifies our code a little bit. So finally, we call the pop method on the items array. Okay. Now the peek method. So peek, once again, I'm going to define a constant items and set it to underline items that get this. First, we check if the stack is empty. So if items, that length is 0, we're going to throw a new error, stack is empty. Otherwise, instead of removing an object, we're just going to return the object on the top. So return items of items that length -1. Very simple. And finally, the count property. Count is a read-only property. We should not be able to set it from the outside. So that's where we use a getter. And as you learned in this section, defining getters in classes is very easy. So get count, that's our count property. We simply return underline items that get this. That returns our private array. So we simply return its length. So that's our stack exercise. In all the examples so far, we have written all the code inside of one file, index.js. But that's not how we build real-world applications, because we don't want to have one gigantic file with hundreds or thousands of lines of code. That's really hard to maintain. So we should split our code into multiple files, and we call each of these files a module. This gives us a number of benefits. First is that we can increase the maintainability of our application, because our code is better organized. Second is that we get the chance to reuse one or more of these modules in different parts of an application or in different applications. And third is that we can abstract code. So we can apply the abstraction principle, which means we can hide some of the complexity in a module and only expose the essentials. Here's a real example. So earlier we wrote this code to implement a private property in our circle class. So we have this radius, which is a weak map, and we're using that inside our circle class to implement a private property. So here, when we create a circle object, we don't have access to a radius property like this. This does not exist. However, in this code, if I have access to this radius weak map, I can read the radius private property of the circle object. So here, I can call radius.get and pass this circle object as the key, and what is returned will be the value of the radius property. So if we log this on the console, we get 10 here. Now, what we should do here is to take the circle class and the radius weak map out of this file, put it in a separate file, which we call a module, and then only expose the circle class to the outside. So we can import that file here, create a circle object, but we will not have access to this underlined radius object, which is our weak map. So this is abstraction in practice. So now you know what modules are, what are their benefits. You might be asking, how can we use modules in JavaScript? Well, Before I tell you the answer, I want to quickly give you a brief history of modules in JavaScript. In ES5, we didn't have the concept of modules, so different solutions emerged to solve this problem. Smart developers in the community introduced new syntaxes to define modules. We refer to these syntaxes as module formats. So the popular module formats we have are AMD, which stands for Asynchronous Module Definition, and this is primarily used in browser applications. We also have CommonJS, which is used in Node. We have UMD, which stands for Universal Module Definition, and this can be used both in the browser and in Node. So we use these module formats in ES5, but as of ES6, JavaScript natively supports a module format. Now, out of this list, we're going to focus only on two formats, CommonJS because that's used in Node, and ES6 modules because that's used in browsers. So technically going forward, you don't need to learn about AMD or UMD unless you're maintaining a legacy application that is built around these module formats. So next we're going to look at CommonJS, and then we'll look at ES6 modules. In this lecture, I'm going to talk about CommonJS module format that is used in Node. So as part of this, I'm assuming you have some basic familiarity with Node. At least you have installed it on your machine and built a simple Hello World example. If you haven't, that basically means you are a front-end developer, so you have only used JavaScript inside of browsers. If that's the case, skip this lecture and watch the next lecture where I talk about ES6 modules. So this code I'm using, if you want to code along with me, you can download this as a zip file attached to this lecture. Now, here in the terminal, we can run this application with node index.js, and we get this message, circle with radius 10. Now we want to modularize this simple program. So here's a basic rule of thumb about modularity. Things that are highly related, they should go together. For example, in your kitchen, you have glasses, plates, spoons and forks, and so on. You don't store your clothes in the kitchen, right? They belong to your bedroom. So things that are highly related, they go together. This is what we call cohesion in software engineering. The same principle applies to code. So in this piece of code, we're going to find things that are highly related and then move them outside of this index.js. Can you pinpoint what parts are highly related? Well, we have this weak map radius that is used inside of this circle class, right? So these two pieces are highly related. We need to take these outside of the index.js and put them in a separate file. So I'm going to create a new file back in the index.js, cut this code, and move it here. Now let's save this as circle.js. So here's our circle module. Now, by default, everything that we define in a module is considered to be private, so it won't be accessible to the outside unless we explicitly export it. The way we export objects in Node or CommonJS format is like this. So here we have this keyword, module, which refers to the current module. This module has a property called exports, and this is an object. We can add one or more properties to this object. So we can add a property called circle and set that to this circle class here. Now, if we had multiple classes here and we wanted to export them all together, we could do something like this. Maybe we had a square class. We would export that like this too. So this module.exports is an object with two properties, circle and square. And then we can import this object inside of our index.js and access these properties. But in this implementation, we're exporting only a single object. So we can simplify this code like this. First, let me remove this line. Now, instead of adding a circle property to this module.exports object, we can just reset this object to circle. So when we import the circle module, we'll get the circle class, okay? Now, let's go back to our index.js or index module. On the top, we want to import the circle module. We use the require function for that. This require function is part of the CommonJS format. So CommonJS format defines this require function and module.exports. This is the syntax that is used in common JS format. Okay. Now, back in index.js, we want to require here a pass, a relative path to this target module. We use period and slash to refer to the current folder, and then add circle. Note that we don't need to add the extension. We don't need to add circle.js because that's assumed by default. Now, when we require this, we get what is returned from this module. So, module that exports represents the object that is exported from this module. In this case, that object is the circle class. So, back in index.js, we get this and store the result in a constant called circle. And then we can use circle to create a new circle object. Now here's the interesting part here. In the circle module, we are only exporting the circle class. So this radius weak map is not accessible in our other modules. This is part of the implementation detail of the circle module. What we're exporting, which is our circle class, is what we call the public interface. So public interface, and radius is implementation detail. So this is abstraction in practice. We're hiding the details or the complexity inside of a module. Tomorrow we may decide to replace this weak map maybe with a symbol or a different object. That change is not going to break the rest of this application because nowhere else we have code that touches this underlying radius object. It's part of the implementation detail of this module, okay? Now, let's save the changes. Back in the index.js, save. So, here in the terminal, I'm gonna run the application again and everything should work. So node index.js, and we get the same message. So this is how we use common JS modules in Node. In the next lecture, we're going to look at ES6 modules. All right, now we're going to look at ES6 modules. Once again, if you want to code along with me, you can download this code as a zip file attached to this lecture. So here in index.js, we want to grab the circle class and the radius weak map and put them in a separate module. And then in that module, we want to export only the circle class because this is the public interface of that module. This is what we want to work with here on line 14. And we want to keep this radius weak map private because this is part of the implementation detail of that module. We don't want that to be leaked to the outside. So let's see how we can use ES6 modules to achieve this. I'm going to create a new file, call it circle.js. Now back in index.js, I'm going to grab the radius weak map and the circle class, cut them, and put them in circle.js. Now by default, everything that we define here is considered private unless we explicitly export it using the export keyword. So here, if we put the export keyword before the circle class, this will be exported to the outside. So when we import the circle module in our index module, we'll have access to the circle class, but we won't be able to work with this radius weak map, okay? So save the changes. Now back in index.js, we import circle, we put it between curly braces. From, here we add the path, period slash to refer to the current folder, and then circle. Now if we refresh the console, we get this error. Syntax error, unexpected token. Now there is a proper way to fix this issue using Webpack, but in this lecture, I'm going to show you a quick workaround. It's not something you want to do in production. It's just for this demo. So we go to index.html. Here is our script element. We need to change the type of this script element to module. With this, our browser treats index.js as a module, so it will understand these curly braces here. Okay, so save the changes in index.html. Now we get a different error. So you can see we have a GET request to localhost port 5500/circle. Because in index.js, we're trying to load this module. That's why we have this HTTP request to this endpoint. But the name of the file is not circle, it's circle.js. So again, as a temporary workaround in this lecture, we need to add .js here, save the changes, and now we get circle with radius 10. Now, what I want you to take away from this lecture is the syntax of ES6 modules. So in circle module, we use the export keyword to export one or more objects. And then in other modules, we use import to import those objects from our modules. All right, now let's talk about ES6 tooling. These tools that I'm going to introduce you to, they're only important if you're building browser applications. If you're using JavaScript in Node, you don't have to worry about these tools. So what are these tools? When using modern JavaScript, we need two kinds of tools, a transpiler and a bundler. Transpiler is the combination of two words, translator and compiler. Basically, it's a tool that we give it our modern JavaScript code, and it will convert our JavaScript code into code that all browsers can understand. Earlier, I showed you Babel. Babel is an example of a very popular transpiler for modern JavaScript. A module bundler is responsible for combining all our JavaScript files into a single file, which we call a bundle. There are many module bundlers out there, but the most popular one is Webpack. So we give all our JavaScript files to Webpack. Webpack will combine them into a single file. It will minify our code by getting rid of all the white space and comments, and then it will uglify our code, which basically means it will shorten the name of our identifiers, like classes, functions, objects, and so on. So this will reduce the size of the bundle that we will serve to the client. So over the next two lectures, we're going to explore each of these tools. In order to install the tools that I told you about, we need Node. Now, at this point, you don't need to know how Node works because we're not going to program in Node. All we need is a tool that comes with Node called Node Package Manager, or NPM. You probably know this, but I want to make sure to explain it very briefly for students who are not familiar with NPM. So NPM is a tool that we use to install third-party libraries and tools. So if you haven't installed Node on your machine, head over to nodejs.org and on the homepage, download the latest stable version and install it. When you're done, open up the command prompt or terminal and run node-v to make sure you have installed Node properly. Now for this demo, I'm going to create a new folder. Let's call that ES6-tooling. Let's go in this folder. The first thing we need to do is to initialize a Node project in this folder. To do that, we run npm init --yes. What this command does is it creates a file in this folder called package.json, which is an identification for our application. Here we have properties like name, version, description, and so on. Now we are ready to install Babel. So npm I, as in short for install, there are three packages that we need to install. So I want you to pay great attention here. Make sure you get the spelling right, as well as the version number. Because chances are, in the future, when you're watching this video, the latest version might be different and it might behave differently. So make sure to install the same version that I'm installing in this video. So the first package is babel-cli. We add @ to specify the version number. The version I'm going to install is 6.26.0. Now the second package is babel-core and its version is 6.26.0. And the last one is babel-preset-env and the version is 1.6.1. Now let me quickly explain what each of these packages are. So babel-cli is Babel's command line interface. It's the tool that we run from the command line, like npm. So we run it from the command line and give it the name of our JavaScript file, and then it will convert or compile that JavaScript code. The second package, babel-core, is basically the core of Babel, where all the logic for transpiling code is implemented. And finally, we have Babel preset. What is this? Well, in Babel, we have a plugin for every new JavaScript feature starting from ES6. So let's say you want to use let and const in ES6, there's a plugin for that. You want to use arrow functions in ES6, there's a plugin for that. So every new feature in ES6 and newer versions has a corresponding plugin. Now, let's say in your application, you want to use only 2 of these new features. So you can install only those 2 plugins. But if you want to have more flexibility, you can install this preset. And this preset is basically the combination of all these plugins. So it understands all the new features in JavaScript starting from ES6. Now, finally, we need to supply a flag here, --save--dev. And this means we're going to install these as development dependencies. So they are not going to be part of our application. They're not going to be deployed to the production. They're purely on the development machine. Let's go ahead. All right, we're done. Now let's open up Visual Studio Code. So in this folder, we have this package.json and package-log.json, which is used internally by NPM. And we have this node modules folder where all these packages that we installed are stored. Now there are more folders here than what we installed. These are the dependencies of those packages. So you don't have to worry about any of this. Now I'm going to add a new file here, index.js, and write some basic ES6 code. So let's define a constant x and set it to 1. All right, now we want to use Babel to convert this to code that all browsers can understand. The first thing we need to do is to go to package.json. Here in the script section, delete what we have here for test. Don't worry about this. We're going to add a new script. And I'll tell you how that works in a second. We call this Babel and set this to a command that will run in terminal. So the command we're going to run is like this. Babel, that's Babel's command line interface that we run from the terminal. Then we add --presets. The preset we're going to use is env. After that, we add the name of our source file, which is index.js. And then we add -o. Output is going to be in a folder like build and then index.js. Now, in order for this to work, we need to create this folder. Otherwise, we're going to get an error. So here in this project, I'm going to add a new folder, build. Now save the changes. So basically the scripts that we define under the script section, we can run them using npm. So if we go to the terminal and run npm run babel, this will execute this command on the terminal. It's faster and easier to type npm run babel as opposed to this complex command. So back in the terminal, npm run babel. Our code is compiled. Now it's stored in build/index.js. So let's have a quick look here. Build index.js. So note that in ES5, we don't have let or const. So our code is converted to something like this. We're using strict mode by default. That's a best practice. And const is replaced with var. Now, this is just the basic of Babel. There is way more to Babel. It really requires its own course. I just wanted you to get a taste of how it works. Obviously, one problem with this setup is that in package.json, we are compiling only index.js. Our application might have hundreds or thousands of files. So we don't want to repeat this for every file. That's where we use Webpack. So with Webpack, we're going to get all our JavaScript files and put them in a bundle. However, before putting these files in a bundle, we're going to run each file through Babel. And that's what you're going to see in the next lecture. What you learned in the last lecture about using Babel was purely for demonstration. That's not the workflow you use when building real-world applications. So in this lecture, I'm going to show you the workflow that you should use on a day-to-day basis. So for this demo, I'm using this project that we worked on earlier. We have two modules, index.js and circle.js. In index, we simply import the circle module. We get the circle class, create an object, and draw it. If you want to code along with me, I've attached this project as a zip file to this lecture. Now open up command prompt or terminal and run this command. npm install -g, which is short for global. We're going to install Webpack CLI globally so we can access it in every project. The package name is Webpack-CLI, and the version I'm going to use, which is the latest version right now, is 2.0.14. Now, if you're on Mac and you haven't configured permissions properly, you need to prefix this command with sudo. All right, so we have installed Webpack CLI. Now in our project folder, we run Webpack-CLI space init. So Webpack CLI is going to ask us a bunch of questions, and based on these, it will create a Webpack configuration file, which used to be painful in the past. You had to jump back and forth in the documentation, but now we can easily generate this configuration file using Webpack CLI. So let's see what these questions are. Will your application have multiple bundles? Let's say no. We're going to have a single bundle. Which module will be the first to enter the application? We need to specify the starting point. So by default, it's suggesting to use index in the source folder. So back in our project, as a best practice, I'm going to move all our JavaScript files inside of a folder. So let's call that folder src and move index and circle there. Okay, now back in the terminal. So the path is /src/index. The next question is, which folder will your generated bundles be in? The default is dist. So we can press enter and accept the default. Are you going to use this in production? For simplicity, let's say no. Will you be using ES 2015 or ES6? Absolutely, because we're using classes and modules. So yes. And when we answer yes to this, this is going to automatically install Babel to transpile our code into ES5. So we don't have to explicitly install all those Babel packages. That's the benefit of using this Webpack CLI. Not only will it help us generate the configuration file for Webpack, but it will also download and install any other libraries and tools that we need. Let's go ahead. The next question is about CSS. We're not going to use CSS here, so no. Again, another question about CSS. If you want to bundle your CSS files, what will you name the bundle? So you can see with Webpack, not only can you bundle your JavaScript code, but you can also bundle your CSS. Again, we press enter to skip. And finally, it's asking us the name of our configuration file. So by default is webpack.config.js, but you can change this if you want. I suggest not to do that. Let's go ahead. Now this is installing a few packages. All right, so here are the packages. It installed Webpack CLI locally. It also installed uglify.js. This is used for uglifying code, which basically means shortening the name of our identifiers. You're going to see that in a second. It installed Babel core. So unlike the last lecture, we didn't have to explicitly install this. It installed Babel loader. In Webpack, we use loaders to pre-process files. So this is like a plugin for Webpack that uses Babel to transpile our files. It also installed Babel preset env, which you're familiar with, and finally Webpack library itself. Now back in the project, you can see here is our Webpack configuration file. All the details we supplied are now stored here. So the next step we need to do is to create a package.json file. So back in the terminal, let's run npm init --yes. Now back in the project, here's our package.json. In the script section, we're going to add a new command, call it build, and set it to Webpack. The only problem with the current implementation of Webpack CLI is that it's storing all these tools like Babel core, Babel loader, and so on under dependencies in package.json. But these are essentially development dependencies, so they should be stored here. But this will probably change in the future. So everything is ready. Now Let's bundle our application. So back in the terminal, run npm run build. So this runs Webpack. You can see Webpack created a bundle called main.bundle.js, and it used these two source files, circle and index. Both of them are in the source folder. So back in the project, here's our dist folder. Here's our bundle. You can see our code is uglified. Look at these short identifiers like T, R, N. There's no white space in this code. There are no comments. And this is basically ES5 code. So Webpack run our code through Babel, and it converted it to ES5. Now we have one JavaScript file to serve to the client. So we go to index.html. Here in the script element, we remove type set to module because this was purely for demonstration earlier. And then change the source to dist/main.bundle.js. Now finally, we go live with this, and you should see this message, circle with radius 10. So this guarantees that everything is working. Our modules are working. Now with the current setup, every time we make a change to our source files, we have to go in terminal and run npm run build. This is time consuming. So let's simplify this. Back in package.json, here I'm going to change this build script to webpack-w. That's short for watch. So with this, Webpack is going to watch our files, and every time we make a change to any of our files, it will automatically regenerate our bundle. So save the changes. Now back in the terminal, we run npm run build. So you can see Webpack is watching the files. It generated our bundle. Now let's go and make a simple change to one of our source files. So let's open up index.js. I'm going to do a console.log I've changed. Save the changes. You can see Webpack regenerated our bundle. And here's our changed message on the console. Also note that earlier, when I was demonstrating ES6 modules, I told you that as a temporary workaround, we had to add this .js extension here. So the browser could request this file from the server. But now that we're using a bundle, we don't need this anymore. So let's delete this, save the changes. Webpack regenerated our bundle and everything is still working. If I refresh, see, we still get all these messages.